Understanding the math behind the BP base block's getAttach location function can further put into focus how vectors are used and provide an example of one way to use a static mesh's normal values. Our objectives for this module are to explain the coordinate system which our game is built on. We'll demonstrate how the getAttach location function uses a normal to figure out which direction a face is pointing. Finally, we'll solve the question of where to place a new block when an existing block is clicked on. Our game is built on a 3D Cartesian coordinate system, defined using an X, Y, and Z axis. To keep things simple, we've made the point of origin of the floor block snap to a grid of 100. In our system, X values increase in a positive direction moving forward, Y values increase in a positive direction moving to the right, and Z values increase in a positive direction moving up. All axes decrease in value in the opposite direction. Unreal units are 1 centimeter. Our blocks are 100 centimeter cubes. In other words, they are 1 meter cubes. We'll use these figures when we determine where blocks will go in the world. In the block game, all blocks have a point of origin in their lower left-hand corner. This is how we specify where to add a new block. We do this by providing the location of the bottom left corner of the new block in global space. Now that we know how the coordinate system is used in our game, the next piece of the puzzle is the normal. Normals on a static mesh define which direction a face is pointing. When we specify normals on the BP base block, we're indicating the values in the X, Y, and Z axis. Normals are normalized values, meaning they have a value between -1 and +1. If a normal's value is -1, it's pointing in the negative direction of the axis that it's specifying. If a normal's value is +1, it's pointing in the positive direction of the axis that it's specifying. If a normal's value is 0, it's perpendicular or on edge. We use a vector to specify the normal. By doing so, we can identify which face was clicked on, or more accurately, where the hit occurred with a line trace. In this version of the block game, I added some additional information to show where the point of origin of certain blocks are. For example, the floor block is showing its point of origin of x0, y0, and z0. On the block that was added, its point of origin is 100 in the x-axis, 100 in the y-axis, and since it's on top of this floor, it's at 100 in the z-axis. The normals on the faces are shown on this specialized block as well. On the face that we're looking at, it's facing in the x-axis in the negative direction, so its x value for the normal is -1, and it is 0 for the y and 0 for the z. On the opposite side of that block, notice that the x value is 1, and the y and the z are both still 0. On the y side, we've got an x of 0, a y of -1, since it's facing in the negative y-axis, and a z of 0. And on top of the block, we see that we've got an x and y of 0 and a z of +1. Observe when we place another block, we get the new coordinates shown on the block, and the x-axis, we're at 300, here's 0, 100, 200, 300 in the x, 300 in the y, so there's 0 in the y, 100, 200, and 300, and we're still at 100 in the x since we're on top of this floor block. If we add a block on top of that, the x and the y stay the same, and the z goes up to 200. When we add one on top of that, we should see a z of 300. Back to the getAttach location function in the BP base block. This function receives two vectors as parameters: the location of where the crosshair was when the player clicked, and the normal, the direction the face that was clicked on was facing. Both of these parameters are vectors. This means that they both contain an x, y, and z value. As an example of how the function works, let's use the floor block at 100 in the x, 200 in the y, and 0 in the z, and work out what happens when a player clicks on top of that block at the location 153 in the x, 229 in the y, and 100 in the z. The cursor in the graphic on this slide approximates that location. The normal value will be 001 because the face that was clicked on is facing in the positive z direction. It's facing upwards. The first node adds the two vectors together, which sounds more complicated than it is. It's just straightforward addition. The x values are added, the y values are added, and the z values are added. In this case, the sum would be 153, 229, and 101. The next node subtracts 50 from the sum of the previous node. Again, it sounds more complicated than it is. This simply subtracts 50 from each of the three axes. The remainder of this subtraction would be 103, 179, and 51. The next node snaps the remainder of the subtraction to a 100-unit grid. This rounds down any axis that's 50.0 or below to the nearest 100, and rounds up any axis that's greater than 50.0 upwards to the nearest 100. The result of this is a vector snapped to a grid that is a vector that defines the attachment point for the next block. 103, 179, 51 would snap to 100, 200, 100. Once again, using a slightly modified version of the game, I've added a cursor that shows where the next block would be if you were to click. And you could see that the math is fairly straightforward. When we are at 0, 0, 0, and we put the cursor right on top of that block, the only axis that's going to change is the z-axis. We're going up 1 whole unit, or 1 meter, or 100 centimeters. And if we click and add that block, we'll get a block at x0, y0, z100. The math works no matter which side or which face we click on. And you could see that it's very fast and very accurate. To wrap things up, the math behind the getAttachLocation function is straightforward. It's addition and subtraction. Using vectors is also straightforward. Vectors are a structure with three values, an x, y, and z. Adding vectors and subtracting singular values from them involves applying the operation to each axis and obtaining the result. Having a good grasp on the 3D coordinate system and a concept such as normals can help you solve more complex problems in the future. In this module, we explained the coordinate system in which our game is built on. We applied the 3D Cartesian coordinates and surface normals as a means to determine which side of a block was clicked on. We determined where to place a new block when another block is clicked on. While it's now possible to build in the game with a base block, having a wide variety of blocks to build with will make the game much more fun. Let's add a dirt block, a grass block, a brick block, and a wood block to get things rolling. Our objectives for this module are to create several child blueprint classes of the BP base block. We'll add a way to switch between which block we're currently building with, and finally, we'll provide a way to remove blocks from the world. To create the new blocks, make sure you're in the Blueprints folder, and then find the Blocks folder and open it. We're going to make child classes of the BP base block. To do that, right-click on the BP base block and select Create Child Blueprint Class. We'll name the first one BP_dirt block. Then open it for editing. Select the block mesh and find the Materials section. There are three materials. Element 0 is the top material. We'll change that to dirt. In fact, we're going to change all of these materials to dirt. Element 1 is the side materials, and we'll change that to dirt as well. And then the element 2 is the bottom. We'll change that to dirt. The dirt block's pretty straightforward. Click Compile and Save, and close the dirt block. Right-click on the BP base block again, create Child Blueprint Class, and name this one BP_grass block. The grass block's a little bit more complicated. Select the block mesh. It will have three different materials assigned to it. So for the top, click on element 0, type in grass, and select MI grass top, material instance grass top. For element 1, type in grass again, and find the MI grass side, material instance grass top. For element 1, MI grass top, material instance grass top. For element 1, type in grass again, and find the MI grass side. And finally, for element 2, type in grass once more, and find the MI grass bottom. Compile and save. For the brick block, repeat those steps. Right-click on the base block, create Child Blueprint Class, BP_brick block, open in the editor, select the block mesh, and type in brick MI brick. We're going to use the same texture for the top, the middle, and the bottom. So brick again, and brick for the bottom. And compile and save. Close that. And compile and save. Close that. And right click on the BP base block, create child blueprint class, BP underscore wood. Open that up for editing. Select the block mesh. Over to the materials. Wood, material instance wood. Wood again. And wood once more. Compile, save, and close the BP wood block. After you finish the project, you can bring in as many materials as you like. You can make your own materials and bring them in and use them on your own blocks and make as many blocks as you like. Before we get to that, though, let's provide a way to switch which block we're currently using. Go to the Blueprints folder and open up the BP block player. Now, this is the code we wrote to spawn a new block, and we should put a big comment around that. So drag and select the whole piece of blueprint code and hit C and type in spawn a block. Now let's observe over here at the very end where we spawn actor BP base block, the class BP base block is the class reference that we're spawning. What we'll do is we'll create a variable for the current block. And then use that here and switch that variable's value depending on which block we want to use to build. To do that, let's add a new variable. Click the Add Variable button and call this current block. For the variable type, click the dropdown, type in BP underscore base block. And from the BP underscore base block, we want a class reference, not an object reference. An object reference is a reference to an instance of the class. We want a class reference, which is going to tell us which class we'll use to build the block with. Let's click compile and provide a default value for that. Now notice when we click compile, this is currently set to none. That dropdown will have all of the classes that are BP base blocks. And that's the thing about inheritance. Although a dirt block is a different class, it's a child class of the BP base block. Therefore, it is a BP base block, as well as being a BP underscore dirt block. So let's set the default block to the BP base block. We'll switch that later. We'll provide a way to switch that, but just set that to BP base block for right now. Drag out the current block variable, do a get on it, holding down the control key. Sorry, I probably said I wasn't going to mention that again, but I did. Let's drag off of the current block and hook that into the class. Now, nothing's changed just yet. We're still making a new actor of type BP base block because the current block has that value. Let's provide a way to change the value of current block. Just find an open area in the event graph, right click, and press the 1 key on your keyboard. And for keyboard event, let's choose number 1. And then let's drag out current block and do a set on that. So we'll say when the 1 key is pressed, we'll set this to BP base block. Right click, type in 2 on your keyboard and select keyboard event 2. And I'm just going to duplicate this node, select it, Control W. And when 2 is pressed, I'll set current block to the dirt block. And right click. When 3 is pressed, duplicate this, Control W. And when that is pressed, we'll set this to the grass block. Right click, 4, duplicate. This will be the brick block. And right click one more time, 5, and duplicate. That will be the wood block. So we're changing the value of the current block variable depending on which key is pressed. I'll highlight all of those, put a comment, change the current block. Now let's test it. Compile, save, back to the map, press play. Now, nothing should have changed. We should be putting down the base block right now. I'm going to tap 2 on the keyboard, and now I'm placing dirt blocks. And now 3 should be grass blocks, and 4, and we've got the brick block, and 5, finally we've got our wood block. So we provided a way to change the current block. The last bit of functionality we'll add for this module is to provide a way to remove a block. Let's find an area near the add block code, and it's going to look very similar to this. It won't be quite as complicated because we won't be turning towards where we're removing the block. So let's right click and type in remove block to get the action event remove block. And in the same way we did a timer and an event and a clear timer, we're going to do those nodes as well, similar nodes as well, just these.
You just scale it? Is that what you do? Okay, there we go. Weird. Okay. I guess that makes sense.
This will be for removing a block. So we'll drag off of the press, set timer by event, and we will right click, add custom event.
Like this.
We'll name this remove block from world, and we'll hook up the delegate, set the time to 0.2, and make sure looping is checked. And finally drag off of that set timer by event node and call the remove block from world event. So it runs immediately when we start doing that. Let's also come right off of the release tab and clear timer by function name. And again, to get the function name right, in case there were any misspellings here, select the custom event, press F2, Control C, come back to function name here, and Control V to paste that in.
It's not going to work well if you rename that
So to do
function.
that, we'll call the get crosshair location function we previously wrote. Look that up. That will return the location of the crosshair. We'll call the get clicked on block function that we previously wrote. And look that up and use the crosshair location as the target. We'll make a branch, hold down the B key, left click.
Get clicked on block.
And if we successfully clicked on a block, we'll need to check if the block is breakable, because we don't want to delete the floor, which is not breakable. And later we might have other blocks that we don't want to break. So we'll drag off of the hit block and type in is breakable to get its is breakable value. And we'll make another branch, B, left click, and make that a condition. And if that's true, or if it is breakable, we'll drag off of the hit block and type in destroy actor. There it is right there. And we'll destroy that block. And I'm going to use a reroute node, double clicking on that wire to neaten that up a little bit. And that's pretty much it for the remove block functionality. I'm going to highlight that. Press C, add a comment, and remove a block. And of course, no code is correct until we test it. So let's compile, save, come back to the map, click play. And let's try using some more interesting blocks. I press 3 to use grass blocks, and then right click to remove those blocks. Let's right click on the floor to test. The floor is not going away, which is good. And now we can really start building and modifying our builds by adding blocks and removing blocks. In this module, we created several child classes of the BP base block. We added a method to switch between which block we're building with, and finally we added a way to remove the blocks from the world. In this lesson, we'll explore the object-oriented paradigm of inheritance. We'll show how we classify new blocks using inheritance, and we'll identify attributes and behaviors that belong in a parent class. We'll also identify the attributes that belong in child classes, and we'll use the block game as our example. We'll use an object hierarchy to avoid writing more code and make expansion of our game possible. It's worth noting that we're not going to discuss everything about inheritance. We'll just look at how we implemented our blocks in the block game using inheritance. Inheritance is the relationship between a parent class and a child class. Now, you can have many child classes, and they can all extend or inherit from a single parent class. The child class inherits all of the data and behavior of that parent class. You can think of it as an instance of the parent class that adds some specialization to it. You can always treat the child class like the parent class because of that, but the same isn't true for the parent class. All parent classes don't implement everything that all the child classes implement. Let's look at the example we used in the block game. We made the BP base block, and it's the parent class of all blocks in the game. The BP dirt block, the grass block, and the stone block are all children of that BP base block. Instances of those three child classes implement the getAttach location function, and the reason they do this is because it's written in the parent class. So we can add special abilities to the child classes. For instance, we can make it so that the dirt block starts to grow grass when it sits uncovered for a period of time. We would only implement that in the dirt block and not the stone block. So therefore, the dirt block is a special child class of the parent class, and the stone block is too. It looks different, and it may have some behaviors of its own. But both of them implement that getAttach location function that's in the parent class. So even with the special abilities that you add to those child classes, you can treat them all as BP base blocks. I made a couple of specialty blocks to use in the block game so we can show how the parent-child class is implemented. The BP base block is on top, and the child classes are on the bottom. The arrow blocks I made just have arrows in them for the static mesh that point up to the parent class. So the dirt block, the grass block, and the stone block are all children of the BP base block. You can consider that they're siblings of one another because they share that parent, but they implement their own materials and their own behavior if we were to add some specialized behavior to them. With a parent variable reference, we can call functions or get data that only exist in the child. But to do that, we have to cast that reference to the child first. We do this in the block game. There's examples of this, and we'll look at them in just a second. We get the HUD from the parent controller, and then we cast it to an HBP crosshair, our specialized crosshair. So the HUD...
Namer, BP, class, row, class, parent manager. Parent badge relay reads message. Hi, Mer. How you doing? Hope you're well. Oh, I can see it. I actually see it there. There's no reaction though.
Variable reference, we can call functions or to them, and their own behavior if we were to add some special, their own siblings of one another because they... The dirt block, the grass block, and the stone block are all children of the BP base block. You can consider that they're siblings of one another because they share that parent, but they implement their own materials and their own behavior if we were to add some specialized behavior to them. With a parent variable reference, we can call functions or get data that only exist in the child, but to do that, we have to cast that reference to the child first. We do this in the block game. There's examples of this, and we'll look at them in just a second. We get the HUD from the parent controller, and then we cast it to an HBP crosshair, our specialized crosshair. So the HUD is the parent class that the HBP crosshair inherited from, and we need that HBP crosshair because we have to get the data from it. When we get the block that was clicked on, we cast it to a BP base block, even though it might be one of the many different types of child blocks that are available. Let's look at the code. In the begin play event, we get the player controller, and then we get the HUD from the player controller. This returns a HUD class. We have to cast that to the HBP crosshair, and we know it's the HBP crosshair because we set that in our game mode as the HUD that was going to be used for our game. Notice that there's the possibility that the cast may fail. Now we, again, know that it's going to be the HBP crosshair, so we're pretty certain that we're going to get a valid HBP crosshair reference from that cast. But if you don't know for sure that you're going to get that child class, you have to take care of the case where the cast might fail. Once it's casted to that type, we can use that reference as the type that we casted to. And in our case, we just capture it as a variable for use later. Here's a case where we deal with the fact that we might not get one of our blocks back in a cast. So in the get clicked on block function, we grab the hit actor, the thing that was hit by the line trace, and we try to cast it to a BP base block. If it succeeds, we return the BP base block so that the code that needs to ask it where to attach the next block can call that function on the BP base block. In the event that it fails, we have the hit success value set to false so that we know that the hit block isn't valid and it's not a BP base block.
God dang it, face rig.
We have the hit success value set to false so that we know that the hit block isn't valid and it's not a BP base block. By checking that we connected with, or our line trace connected with, an actual BP base block, we can write code that deals with the situation where it's successful and not successful. Another place where we use inheritance is we have the all blocks array. That's an array reference to BP base blocks. With the exception of the 0th element, which we put a BP base block in, all of the classes listed are children of that BP base block. Since the child classes have the full power of blueprints, they can implement completely customizable behavior. Let's look at the example of the BP random flower block. The BP random flower block changes the static mesh in the construction script. None of the other blocks we've built up to now do that. So let's look at it. The block mesh is set to the SM_flower daisy01. Now, if we did nothing, we would always get that flower block or that static mesh every time we made one of these. But in the construction script, we implemented some specialized behavior. We've got a...
We didn't do that! I didn't add a flower. I want a flower.
Random integer from 0 to 2 being taken, and then option 0 returns the daisy01. Option 1 returns the daisy02, and option 2
Huh.
returns the daisy03. And then we change the block mesh in the construction script.
I'll go back, see if I can figure out how to add that if they don't actually cover
The
this
result of this
tutorial.
is, when we play the game, every time we put down a block of type random flower block, we'll get a random flower. Let's look at that in the game. I'll scroll to the random flower block.
Scroll!
And when I click an edit,
Scroll!
we get a random flower each time. Now you could...
I think this review is in the wrong place. I think we're gonna, yeah, I think it'll be done
get
later.
the same flower several times in a row like I did there, or you can get a different flower. Now, notice that this is a BP base block. When we click on it, it tells us the next location to add, and that code works. So we can treat it like any other block, and we can remove them by right-clicking or running the remove block action. And by using the power of inheritance, we've created that specialized block, the random flower block. Let's look at the all blocks array again. The all blocks array has class references to BP base blocks. The 0th element is a BP base block. All of the child classes are children of the BP base block. When implementing inheritance of
All blocks.
the
That's
BP
got to
base
be
block.
something we don't do yet.
When implementing inheritance in your games, take your time to carefully analyze the relationship of the actors in the game. Sometimes an object hierarchy makes sense, and sometimes it doesn't. Sometimes you can implement the differences between child classes with data. For example, we could have used a way to change the material of the BP base block so that the material changes. But by implementing it the way we did, we allowed for having specialized blocks as the child classes, for instance, the random flower. You can add all kinds of interesting behaviors to the child classes in this game. I was experimenting with blocks that blew up after 5 seconds and took out blocks around them. I had blocks that had lights, blocks that had fire, and just had fun creating all kinds of different blocks just to experiment with and try them out and see what it looked like. And by using this parent-child relationship, it made it very easy to do that. In this lesson, we discussed classifying new blocks using inheritance, and we identified some attributes and behaviors that belong in the parent class, for instance, the get actor location and the static mesh that represents the block. We identified attributes that belong in the child classes. For instance, we could change the static mesh, or we could add things like fire or some ability to have a TNT type block or an explosive type block. We demonstrated the object hierarchy that avoided writing more code and made expansion of our game possible. It's desirable to have a flying mode for the player. We'll accomplish this by writing code to toggle the flying mode and an axis input to move up and down while flying. It's also nice to have some kind of feedback, such as sound, when you're adding or removing blocks. Our objectives for this module are to use a variable to count the number of taps to start flying, and we'll use the spacebar for that. We'll also respond to movement input on the z-axis when we're flying. Finally, we'll add sounds when adding blocks and removing blocks in the game. To get started, open up the BP block player. Locate the code that we previously wrote for jumping. Now, flying and jumping are actually tied together because we jump using the same key that we're going to use to fly with. Let's find the jump code, and in fact, I see we have some uncommented code here for moving forward and right. I'm going to take care of that bit of housekeeping by selecting it and tapping C, move forward, and move right. There we go. And sorry, let's go back over to the jump. It just drives me crazy when I leave code undone like that or uncommented. All right, so back here in the jump, when we jump, we're going to count the number of times we tap the jump key, and if we've tapped it twice within a certain period of time, we'll start flying. We'll need 2 variables for that. So let's create the variables. We'll click Add Variable, and the first variable is called the Fly Tap Counter, and that will be type int or integer. And we'll need another variable, so click Add Variable, and this will be the Fly Tap Delay, or how long we'll wait to delay between taps before we start flying. And this is going to be a float. And let's click Compile. Let's set the default value for the fly tap delay to 0.2 seconds. You can adjust this later if you need a longer time to delay, or you feel it needs less time to delay. So when we jump, when we hit the spacebar to jump, we're going to start counting the number of taps. Let's drag out the fly tap counter, do a get on that, and we're going to increment its value by 1. So drag off of the fly tap counter and type in ++ and get the increment int node and hook that up. Then we'll go into a branch and we'll check whether or not the number of taps is greater than or equal to 2. So B for a branch, and then drag off of the result value of the fly tap counter of incrementing it by 1 and type in greater than and select greater than or equal to and use 2, the number of times we have to tap in order to start flying. Use that condition in the branch. Let's take care of the false part of that branch first, and don't forget to hook up that execution wire right there. So for the false, we'll have a delay. In other words, we haven't tapped twice yet, and we'll use the fly tap delay as the duration for the delay, and that's going to get hooked up to the false pin. And we'll delay for that amount of time, and if that amount of time elapses, we'll set the false, or the fly tap counter, drag that out and do a set on it, and we'll set that back to 0 if we have not started flying yet in that amount of time. If we're not flying and we double tap the spacebar, we want to start flying. And if we are flying and we double tap the spacebar, we want to stop flying. We'll use a flip-flop node for that. So drag off of the true and type in flip-flop. And this great node, I love this node. The first time it runs, we'll execute pin A, and the second time it runs, we'll execute pin B, and then pin A and pin B, and so on and so forth. And it's just a really useful node for this kind of code. So we'll need the character movement component, drag that out and drag off of that, and set the movement mode. And we're going to need 2 of these, so select the set movement mode, duplicate it with Control W, make sure to hook up the target for that. So when pin A fires, we'll change the new movement mode to flying. And then the next time, when pin B fires, we'll change the new movement mode back to walking. And that's it. That'll start us flying and stop us from flying. Now we're almost ready to test this.
That is a little disgusting.
Hit C and
that
type
is
in flying.
ridiculous,
It's
crazy.
connected to jumping, but it's kind of separate
Wow.
code. And let's confirm that we've got our input set for moving up and down while we're flying. So click on Edit, Project Move, almost ready to. And that's it. That'll start us flying and stop us from flying. Now we're almost ready to test this. I'm going to select all that code, hit C, and type in flying. I know it's connected to jumping, but it's kind of separate code. And let's confirm that we've got our input set for moving up and down while we're flying. So click on Edit, Project Settings, go down to the Input section, and setting up and down while we're flying. So click on Edit, Project Settings, go down to the Input section, and observe that we have a Move Up axis mapping. And when the space bar is held down, the axis value will be 1, and when the left shift is held down, the axis value will be -1. You'll see how that's used in just a moment. Close out of the project settings. Right-click and type in Move Up, and we want the axis event, Move Up. Scroll in, and all we need for this is to add movement input. So right-click, Add Movement Input, and hook that up. And we're going to add movement input in the Z axis, up or down. And you'll see Y up or down in just a second. So we're going to change the world direction to Z of 1. For the scale value, the axis value, it'll be 1 when we hold down the space bar, -1 when we hold down the left shift key. So if we're holding down the left shift key, it will apply that scale value to this world direction, and it will become -1. And the space bar has a value, an axis value of 1. It'll become 1. So let's drag around that. Press C for comment. Movement while flying is a good comment for that. Compile and save. And again, the code doesn't work till you test it. Let's go back to the map. Click play. And we can still place some blocks. And let's double tap the spacebar. Now we're flying. And hold down the shift key to go down, and spacebar to go up, and double tap the spacebar to stop flying. So now that we've got the flying code all set, let's go back to the BP block player and let's add some feedback in the form of sounds when we're placing blocks and removing blocks. So find the section where we're spawning a block and feedback. Let's go back to the BP block player and let's add some feedback in the form of sounds when we're placing blocks and removing blocks. So find the section where we're spawning a block, and at the very end of that, you'll see where we spawn an actor, we have a return value. And what we should do is test if that return value is valid, meaning an actor was actually spawned. Because of the collision handling, we may not spawn a block. It may have been colliding with another block and it didn't get spawned. So we need to check if it actually got spawned. Let's drag off of the return value and type in is valid. I always get confused which one I want. Oh, it's not that one. So is valid, drag off of that. Is valid. We want the one with the question mark. There we go. And we're going to execute that. And if it is valid, we want to play some sound at location. So right click and type in play sound at location. We need to furnish a sound asset. We have one of those set for us. So on the is valid, hook that up to the play sound at location. And for the sound asset, we want to use the place block sound. And for the location, we go all the way over here and get the attach location where the block is being attached to and drag that over here. And you might want to use some reroute nodes. Again, that's double clicking. Those are really handy to neaten things up. There we go. And that will play the place block sound at that location where we added the block. And for the remove block, after we've destroyed the actor, we can drag off of that. Again, we're in the remove block code if you didn't see that. Block, destroy actor, we'll drag off of that. Play sound at location. And I'll drag the comment out around that. That'll be the remove block sound. And for the location, we'll take the location of the clicked on block, the block that we clicked on, and hook that up. For the location, double click to add a reroute node. There we go. And let's test it. We'll pick a different block. There we go. So there's our add block sound. And when we right click to remove, we are playing the remove block sound. In this module, we used a variable to count the number of taps on the spacebar to start flying and also to stop flying. We added some input movement in the z-axis when we were flying, when the spacebar was held down, or we would go up, and when the left shift was held down, we would go down, and all in the z-axis. We also added sounds when adding a block or removing a block.
Okay, I'm easily amused.
In this module, we'll learn about using an array to keep track of all the possible blocks in the game. By doing so, the player will have a practically infinite number of blocks at their disposal to build with. Our objectives for this module are to use an array to keep track of the available blocks in the game. We'll learn how to access an array correctly, taking precautions to avoid accessing the array with an out-of-bounds index. We'll switch the active block using inputs from the mouse wheel. To get started, go to the BP block player and open it for editing. Click the Add Variable button and change the new variable name. Open it from the mouse wheel. To get started, go to the BP block player and open it for editing. Click the Add Variable button and change the new variable name to All Blocks. In the Details panel, change the variable type from Boolean to BP_BaseBlock and make sure that you choose Class Reference. Recall that a class reference keeps track of types of things, while an object reference keeps track of references to actual things, or, in other words, instances of things. Since we're using an array of BP base block, any blocks we create that are children of the BP base block can be in this array. The power of inheritance is once again allowing us to write code using general descriptions, base blocks in this case, that will work seamlessly with the specialized child classes in our hierarchy. Just to the right of the variable type, click the menu and select Array. Then click Compile and Save. An array of class references, in this case, allows us to add as many elements that we need to the array, all under the name all blocks. So just to the right of all blocks, it'll tell you how many elements are in the array, and right now there's 0. Click the plus sign 2 or 3 times, and then just below where we added the array elements, you'll see the indexes 0, 1, and 2 of the elements that we just added. Now the class reference is set to none. Click that drop down, and you'll see that we can now choose all of the BP blocks or the blueprint blocks that we created that are child classes of the BP base block. For the 0th element, I'm going to choose BP base block. But for the first element, I'm going to choose the dirt block. And for the next element, I'll choose the grass block. And I've got several more elements to add, so I'll just click Add Element. And then after the grass block, I'll add the brick block. And finally, the wood block. Now the default value gives us a nice picture of the array. And I want to point out a couple of attributes of arrays. There are 5 elements in this array, but the last index in the array is 4 because arrays are indexed starting at index 0. So the 0th index is the first index in the array. Click Compile and Save. We're going to need some variables to support changing the block using the all blocks index. Click the Add Variable button and name this variable current block index. Over in the details, change the type to an integer. Just to the right of the variable type, we'll change that to a single variable, so it's a single integer value, and click Compile. The default value of the current block index is 0, and that's just what we need. Next, find the begin play event. And I noticed that I set the comment to begin player, which is somewhat true, but I want to change that. I'm going to select that, press F2, and begin play. So in the begin play event, what we need to find out is what the last index is of the all blocks array. To do that, get the all blocks array, and then drag out of the all blocks array and type in last index. And that returns an integer that is the last index of the array. Right-click on the return value of that and promote it to a variable, and call that the last block index. And the reason we're making a variable for this is because we'll need it a few times, and we can avoid writing this code several times by just making a variable for it. Now the last index, I'm going to click on all blocks to demonstrate that again. The last index is 4 in this case, but if we were to add more elements, add more blocks, that number would increase. We won't have to change this code because this will pull the last index from the all blocks array when the event begin play starts. Next, we need to add inputs so that we can use the mouse wheel to change the current block. Click the Edit menu and go to the project settings, and then select Input from the list on the left. We're going to add 2 action mappings. Click the plus next to action mappings 2 times. Go to the first one, do action mapping 0, and we're going to name this select next block. And for that, we will search for mouse wheel down. For the next one, we'll call that select previous block, and we will search for mouse wheel up. Close the project settings. Find an open area on the blueprint to start writing some code. Add the 2 inputs that we just added. So right-click and type in select previous block, and right-click and type in select next block. We'll be previous block that we just added. So right-click and type in select previous block, and right-click and type in select next block. We'll be adjusting the current block index. When we select the previous block, we'll be decrementing it or reducing its value by 1, and when we select the next block, we'll be incrementing it by 1. So let's drag out the current block index and get it. We'll start with the select previous block. Drag off of the current block index and type in -- for decrement int. That will reduce the value of the current block index by 1. And we have to be careful because if it becomes less than 0, that would be an out-of-bounds array access. So we need to test and see if it has become less than 0. Drag off of the result of the decrement operator and type in greater than and select greater than or equal to. And it's already got 0 for the other operand. Add a branch, hold down the B key, left click, hook that up, hook up the condition. If the current index is not greater than or equal to 0, it's less than 0, so this condition will be false. If that's the case, we have to set the current block index to the last block index. So drag out a set for current block index, hook that into the false wire for the branch.
Actually, no. This. If I want it to wrap around, and this go to 0. Minus minus. Greater than 0. False. Set current block to last block. Plus plus. Greater than equal to last block index. True. Set block to 0. Let's see
And
if I
the value we're going to
guessed
set the current
correctly.
block index to is the last block index. Do a get on that and set that. If the current block index is greater than or equal to 0, then the true wire will run, and we can set the current block to that index. So to do that, we're going to drag out the current block variable that we previously created, and we were changing.
Oh, right. Okay, because it actually has to set the current. Wait, no, but. Oh, current. Wait, what? Oh, current block. Got it. Oh, okay.
Using the number keys, and we're going to do a get on the all blocks array, and drag off of the all blocks array and type in get, and the get node needs to know which index we're going to get, which is going to be the current block index. So do a get on that and hook that up, and then set the current block to the value retrieved from the array, and hook that up here and here. So if it's true, we don't need to adjust the current block index. And if the current block index became less than 0, we set it to the last index. And we should be able to change our current block with the mouse wheel, but it's only going in one direction right now. So the code to go in the other direction is very similar. We'll drag off of the current block index, type in ++ or increment int, and we'll test the result of that if it's less than or equal to the last block index. Drag out the last block index, get that, and that will be our condition. Whether or not adding one to this has left it less than or equal to the last block index. So we need a branch, B, that up, hook up the condition. Let's move this over to the side a little bit. So if this is false, we want to wrap around to 0. So set the current block index to 0 if this condition is false. And if it's true,
This is wrong. No, that's right. Wait. No, because last block ending. No, that. This is wrong. How do I? Can you change a node? Can you just replace a node? It should just be straight up greater than. They used less than or equal, so their logic is different, but is there any way to do that? Oh shit, I can't imagine there is. I think you just are screwed and you have to reroute everything. Plus virtual. Plus if greater than last block index. So that's right, you know, I think simply from an ordering standpoint, I'm gonna like do the route better. That's alright, I'll use route out.
Good to go. We're within the range of block indexes. So all we need to do is hook up the true to set the current block, retrieving the current block index. And if it was false, we set the current block index to 0 and hook that up. Let's compile and save and test it out and see if we can change the current block with our mouse wheel. So that's the BP base block. I'm moving the mouse wheel forward. Oh, not far enough. There we go. So those are the previous blocks. And then going towards me, I've got the dirt block. Roll it again. Grass block. There's the brick. More brick. And back to the wood. Roll it one more time towards me and back to the base block. And when you test this, make sure you test in both directions to ensure that your code is working correctly. In this module, we added an array to keep track of available blocks in the game. We accessed the array correctly and avoided accessing the array with an out-of-bounds index. We switched the active blocks using inputs from the mouse wheel.
Blink, 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 blink. It's as good as that blinking. Well, then there's this one. Not even. But then you can do them both at the same time. Just going to retaliate. Yeah.
In this lesson, we'll review arrays in Unreal Engine. We'll observe the properties of an array and show a couple of examples of how arrays are accessed, especially in our block game. And we'll look at areas where arrays can make programming more simple or easier and less error-prone. We'll demonstrate the way that we used an array in the block game and explain how arrays are indexed and, very importantly, what an out-of-bounds access to an array means. Let's define what an array is. An array is a container for things or variables or items, and it's a way to refer to multiple items with the same name, but use an index into the array to get or access each one of the items. The index starts at 0 and ends at the number of items in the array minus 1, or the length of the array minus 1. I'm going to demonstrate arrays using a block I built in the block game specifically for that purpose. What this block does is it adds a child of each of the blocks in the all blocks array to the new array and displays the index of that item above the block. So let's put some terms on the array. This array starts at index 0 with a BP base block in that slot. The index is then incremented by 1 for each new item added to the array. And on the last item, the index is 6. When we talk about this array, we say it's starting at the 0th index and ends at the 6th index, and the length of this array is length 7. So the last valid index is the length minus 1, which would be 6. If we add an item to this array, we then have 8 items in the array, 0 through 7, and the last index is now 7. Now in Unreal Engine, arrays can be expanded or contracted. You can add items to them or take items away. This is not the case in all computer languages. Java, for example, has arrays that are set length when they're declared or instantiated. Java does have an array list, which can work just like the arrays in Unreal Engine. In general terms, all of the items in the array have to be the same type. So, for example, if we had an array of ints, we could only put integers into that array. However, if you're using inheritance, all of the things in the array can have the same parent class, but they can be different child classes. And that's how we're using this with the BP base block. Referring back to our example, we have the BP base block as the parent class for all of these child classes. So we can store any of the child classes in the array. There are numerous nodes to work with arrays in Unreal. The most common is to get an item from an array, and for that you use the get node. You provide the index of the item into the array, and Unreal Engine returns a copy of that item from the array. Another version of the get node returns a reference to the item in the array. And in this case, you can change the item by using one of the set nodes for that particular item type. If you want to change the array at runtime, you can use the add node. The add node takes the array that you're adding an item to, the item that you're adding, and then it returns the index of the newly added item. The new item is added at the end of the array. To set something in an array, you provide the array, the index that you want to set, and the item that you want to set it to. This will replace the item at that index. If the index is specified past the end of the array or past the end of the length of the array, you can check the size to fit option and expand the array. If you don't have the size to fit option checked, it won't expand the array and adding the item will fail. You'll also get an error in the output log. To remove an item from an array, you can either use the remove at a specified index node, or you can furnish the item that you want to remove and it will be removed from the array. It's important to note that there are side effects from removing an item from an array. To demonstrate,
It's coming arrays. Goodness. That's silly, bro.
the side effects of removing an item from an array, we'll use our previous example. I'm going to remove the third item from the array, or actually the fourth, but the item with the third index, with the index of 3. What's going to happen is all of the items past that index will move down one index. Now, they won't visually move to a new position, but their indexes will change. So I'm going to right-click on the item at index 3, and you'll see that index 3 was removed, and the one just past it, the item just past it, became index 3. The one past that became 4, 5, and 6, and now our array is now size 7, or length 7, and if we remove the item at index 3, our array shrinks again. So all of the items move down 1 to fill in the gap. Now, that doesn't happen visually here because these blocks aren't moving, but it does remove the item and the index, and it doesn't leave a hole in the array, if you will. It moves all of the items down. That's a very important side effect to keep in mind if you remove something from an array. Now, it's really important to note that the shifting of these indexes can cause us to refer to the wrong block in our case. For example, this purple block was previously index 5, but the result of removing the 2 blocks before it has moved it down to index 3, and now if we were still referring to index 5, we would be getting the teal block instead. So another example of the result of this side effect of removing an item from inside an array. A very common operation on arrays is to iterate through the array, or do something to each item in the array. For that, we use a for each loop. A for each loop takes the array as its parameter, and then it has a loop body. And in the loop body, it gets each of the elements of the array one after the other. It also tells you what index that item is in the array. In this code that's demonstrated here, we just print out the index and the item value using the print string node. After the loop body runs, the completed node runs, and it prints finished. In the block game, we use an array to keep track of all of the actors that are a child class of the BP base block. By using an array like this, we can keep track of the current block by using an index into that array. We don't need separate variables to represent every possible type of block. This makes adding blocks to the game very easy, and it also makes changing the block straightforward, as we can use addition and subtraction to keep track of the current index. Let's take a look at that code. Let's look at the all blocks array first. The all blocks array has a BP base block as the type. More accurately, it's a BP base block class reference. What that means is that all classes that extend BP base block can now be placed into the all blocks array, and we have several of them here. In the begin play event, we access the all blocks array and call the last index node and save that last index to the variable last block index. We use that when we change the current block that we're working with. Let's take a look at that code. We have 2 actions: select previous block and select the next block. The select previous block takes the current block index, which is by default set to 0, and subtracts 1 from it. Let's say we just started the game and we did the input action select previous block. So we reduce current block index by 1, which makes its value -1. We check the value. Is -1 greater than or equal to 0? It is not. So the false condition is run. We get that value from the last block index, and we set the current block index to that. We then retrieve from the all blocks array the current block index, which is now the last block index, and we set the current block to that, which is the last block in the all blocks array. And then we set the preview block. Now let's take a look at what would happen if, say, for example, we've got 11 blocks in our all blocks array. The last index is 10, and the current block index were equal to 10. We select the previous block. 10 minus 1 is 9. 9 is greater than or equal to 0, so the true wire runs. We access the current block index, which is now 9, and we retrieve the block right before that and set the current block to that. And again, we would go backwards, if we were selecting the previous block, to 8, 7, 6, 5, 4, 3, 2, 1, and so on.
This
Finally, when
basic
we got
array
to 0,
logic that I
if we tried to
definitely
select the
already
previous block
understand.
again, we would access the last block because this code would change the value of the current block index to the valid last block index. And it's important that we do that because we avoid doing an out-of-bounds access on the all blocks array. There is no index at -1. Let's take a quick look at how the select next block works, which is very similar to this, but going in the opposite direction. Let's say we start the game, current block index is set to 0, and we fire the select next block input action. We add 1 to current block index. We then ask, is 1 less than or equal to the last block index, which in our case is 10, and in fact it is. So the true wire runs, we get the current block index, which is now 1, and we retrieve the block at the first index from the all blocks array, set the current block, and then set the preview block. This continues. If we keep selecting the next block, adding 1 to it, going down through the list, we get to 10. Finally, we add 1 to the current block index. It now equals 11. 11 is not less than or equal to the last block index. So the false pin runs, and the current block index is wrapped around and set to 0, again avoiding an out-of-bounds access to this array because there is no index at 11. Now, if you do have an out-of-bounds access in Unreal Engine, your game will not crash or stop working, but you will get an error in your output log. Other languages, Java, for example, will throw an exception when you have an out-of-bounds access. And it's never good form to have an out-of-bounds array access, even if the language you're using does not force your program to crash. It's not good programming. These are the 3 main documentation links for array use in Unreal Engine. I suggest you take a look at them because there's many more nodes available for arrays and a lot of information on these documentation pages.
If I botched it, something either that or maybe it's out of date. This is all plus plus. Apparently this is common. I don't particularly like it, but I get it. That. I guess I could learn to like it. I see its benefits.
In this module, we discussed the properties of an array, and we showed an example of how to access an array. We identified an area where arrays can simplify programming, such as with our all blocks array. And by doing that, we demonstrated the use of the all blocks array in the block game. We also talked about what an out of bounds access would mean and how to avoid them. It would be nice to have a visual indication of what the current building block is. The method we'll use here will allow the player to appear as if they have a block in their hand. Another nice feature would be to switch between third-person view and first-person view, and the ability to zoom the camera in and out. Our objectives for this module are to implement a visual indication of what the current block is. We'll also support switching between third-person and first-person view, and implement a way to zoom the camera in and out. Start off by opening the BP block player. Go to the Viewport tab, and then select the mesh from the list of components. Click the Add Component button, and search for Child Actor. Name the child actor Preview Block. The Preview block will be attached to a socket that was created and added to the skeletal mesh. In the Details panel, find the parent socket, click the search icon next to it, and select Block Socket. I'm going to give you a specific set of values for the transform for the location, rotation, and scale. You can modify these later. I'd suggest that you start with these and see how it looks first. For the location, X, Y, and Z, we'll use -7, 6, and 0. For the rotation, for the X, 1, 10, and for the Y, -80, and for the Z, -150. Click the lock icon in the scale setting, and then in the X edit box, type in 0.4. Press enter. Notice with the lock icon selected, all three of the axes are locked and they'll all scale to 0.4. Set the child actor class by going to the child actor class setting in the details, clicking the drop down, and searching for BP_base block. Click compile and save, and observe that you now have a base block attached to the player, location where the socket is, which is right on the player's hand. Go to the event graph. We're now going to add a function to set the current build block and change the preview block. To do that, click the Add Function button and name the function setPreviewBlock. The setPreviewBlock will use the components and variables that are already set up, so we won't need any parameters. Drag out the preview block and drag out the current block class and get it. From the preview block, drag off of that and type in setChildActorClass. Find the setActorChild class node. Hook that up. Use the current block as the class that we're setting that to. Drag out the preview block again.
I don't remember setting current block. I mean, that's true. But I know how to do that, but I don't think they said it. I don't think they did that. No, set current block. Wait, didn't you? Where's current block? Oh, it's way up there. Okay, I'm being a derp.
In the preview block, drag off of that and type in set child actor class. Find the set actor child class node. Hook that up. Use the current block as the class that we're setting that to. Drag out the preview block again, and from that, drag off the child actor. Get child actor. Cast that to a BP base block and hook that up. We need to take the collision from the BP base block and set it to no collision, otherwise the preview block will interfere with the player. And the preview block really shouldn't have a collision because it doesn't respond to anything. It's just being attached visually so that we can, or attached to the player so that we can visually see what the block is. So drag off of the as BP base block and type in box collision to get the box collision. From there, drag off and type set collision enabled. And we want to use the setting no collision. Go back to the event graph and enable. From there, off of the as BP base block and type in box collision to get the box collision. From there, drag off and type set collision enabled.
Get box.
And we want to use the setting no collision. Go back to the event graph and find the spot where we set the current block.
Dude.
From there, collision.
Variables default. Get box collision. There you are. Bloody heck.
To get the box collision. From there, drag off and type set collision enabled. And we want to use the setting no collision. Go back to the event graph and find the spot where we set the current block. And that is right here. And I think it'd be a good idea to put a comment around that while we're here. So I'm going to highlight all of that, tap C, set current block. So at the spot after where the current block is set, drag out a set preview block function call and hook that up. We'll also want to put the set preview block function call in the begin play event as well. So I'll drag one out here, and after we set up the all blocks array and get the last index, I'll just hook that up. And the reason we're doing that is so that that collision gets taken off the preview block. Compile and save and go back to the map and check it out. So now we have a block attached to us, and when we move the mouse wheel to change the block, we see the current block is changing, the preview block, and it is in fact the block that we are using when we place a block down. Another nice feature to have would be the ability to switch back and forth between the third-person view and the first-person view. To add that, we'll need to add an action mapping, so we'll open up the project settings, click on the edit menu and project settings, and then go to the input settings and add a new action mapping. Name the new action mapping toggle FPV underscore TPV for first person view, third person view. And I'll use the keyboard F key for that. And close out of the project settings. Find an open area to write some code, and then right click and search for that new action mapping that we just added. Toggle FPV, there we go, TPV. All right, so since this is a toggle, we'll make use of the flip-flop node. Just drag off the pressed and type in flip-flop. And for the A wire, we'll toggle from third person, which is the default view, to the first person view. So we're going to need the mesh, and what we'll do is we'll hide the mesh, show the mesh when it's time to go back to third person. There's other settings we'll have to change, but that'll be the first step. So drag off of the mesh and type in set hidden in game and hook that up to the A pin. And we want the mesh to be hidden. And I'm going to organize this specific manner here because these nodes are going to be the same for the B option. We're just going to have the settings be a little bit different. So after we hide the mesh, we have to adjust where the crosshair is. So I'll get the crosshair and drag off of that and type in crosshair Y location. Set crosshair Y location. And shift of that is, so I'll get the crosshair and drag off of that and type in crosshair Y location. Set crosshair Y location. And in third person view, it's a quarter of the way down the screen. For first person view, it would be good if it were directly in the center of the screen. So we'll set the Y location to 0.5. We'll adjust the length of the spring arm. So drag off the spring arm and type in target arm length. And we want to set the target arm length. We'll set that to 0 for first person view. And I'm going to keep moving this over because there's quite a bit of code that we have to add here actually. So get yourself a nice wide open space to do this. All right, so the next thing we need to do is tell it to use the controller rotation yaw. Set use controller rotation yaw, and we want that to be true so that first person view, we just use the rotation yaw and directly turn. We're not turning a character. Now these next bits of code are a little bit strange, and what they have to do with is the way the animations work when the skeletal mesh is hidden. When we hide the skeletal mesh, the animations might play for a few frames, and it will leave our preview block in a strange location until we start playing the animation again. This also affects the animation montage when we place a block. So what we're going to do is we're going to detach the preview block from the mesh's socket when we're in first person view, and we'll reattach it when we go back to third person view. There's another way to do this, which is, I'll show you this just so you can try it if you like, and you won't have to write the pieces of code that follow. In the mesh component, you can go down to the optimization section, and where it says visibility based tick option, always tick pose. This will work only when rendered, but it will work partially when you hide the mesh, and then it will stop working. You could change that to always tick pose and refresh bones, and then it will always do the animation even when the mesh is hidden. The problem is in first person view that the preview mesh is going to be flying around all over the place because it's attached to the hand and it's going to be waving around in front of you. You can try it if you like. I found that I didn't like it, and I went with this code that we're about to write here. So let's continue with that. Let's drag out the preview block, and we'll also need the mesh. And the first thing I want to do is I want to get the relative transform of the preview block so that I could set it back to that relative transform when we show the mesh again. So I'm going to drag off of that and type get relative transform, and I'm going to save that to a variable so that we can use it when we toggle back. So I'm going to right click and promote to variable, and I'll name that the previous preview block transform. And let's hook that up. Now that we have the previous preview block transform, we can attach a component to a component, which is really just going to detach from the socket. You'll see that in a second. So drag off of the preview block, attach component to component is what we're looking for. And again, we're going to have to move this code. There we go. That should be the last time for that, hopefully. And there we go. That should be the last time for that, hopefully.
Hey. Wow, as soon as... Yeah, that's annoying, but whatever.
And hook that up here. And preview block is going to be attached to the mesh, which it already is, but we're clearing out the socket name this time. And we want to keep the location rule of the preview block to the world location. So keep world, and scale, keep world as well. So this will now work as far as toggling to first person view. Let's test it out. Let's compile, save, go back to the map, first person view. Let's test it out. Let's compile, save, go back to the map, click play. And you can see I could tap the F key and switch to first person view. Still have the preview block attached. It still changes, but it doesn't animate when we move it around, and it doesn't do the animation montage because it's not attached to the socket anymore. And we can tap the F key all we want. It won't just toggle back because we haven't written the code for the B side of this flip-flop. Do the animation montage because it's not attached to the socket anymore. And we can tap the F key all we want. It's not attached, and it doesn't animate the F key and say it out. Let's compile, save, go back to the map, click play. And you can see I could tap the F key and switch to first person view. Still have the preview.
All right, looks like theirs is doing the same thing. I think I was just looking down more than they were. Yeah, so like I just happened to look really far down.
Block attached, it still changes, but it doesn't animate when we move it around, and it doesn't do the animation montage because it's not attached to the socket anymore. And we can tap the F key all we want. It won't just toggle back because we haven't written the code for the B side of this flip-flop. So for the B side of the flip-flop, we're going to duplicate the set hidden in game. So select it, press Ctrl W. Make sure you hook up the mesh as the target and hook up the B pin to that. And for the new hidden value, we want it to be false. We don't want it hidden in game anymore. We'll duplicate the set Y location for the crosshair. So select it, Ctrl W, and hook that up. Make sure you hook up the crosshair target and set the location back to 0.25. The spring arm, select the set target arm length, duplicate that, hook up the target, hook up the execution pin, and change that to 300, which was the original length of the target spring arm. And for use controller rotation yaw, we want to set that to false. Now we just need to reattach the preview block to the mesh. So I'm going to select the attach component to component, duplicate it with Control W, and hook up the execution pin. We want to attach the preview block to the mesh. The socket name is called block socket, spelled as you see here. And for the location, it doesn't really matter what you put here because we're going to reset that in just a second. So just leave that to keep world. And what we'll do is we'll set the relative transform of the preview block so it'll be snapped back to where we originally had it. So I'm going to drag off of the preview block, bring that over here, set relative transform, hook that up, and then get the previous preview block relative transform, drag that out, and that up like so. Let's compile, save, and go back and test this. Play, press F to change to first person view, press F again to toggle back to third person, and confirm that the preview block is in fact attached in the right location. Let's go back to the BP block player and comment this big chunk of code that we just wrote. So I'll select all of it, press C.
Oh, that's wrong.
For the comment toggle.
Right. Oh, the spring arm's messed up. Hey, forget a minute.
Press F again to toggle back to third person and confirm that the preview block is in fact attached in the right location.
Oh, right. I had a bug.
Press F to change to first person view. Press F again to toggle back to third person.
Yeah, and I'm pretty sure I already know what my bug was. Because the total arm length is still set to 0. What did they set their arm length to? $300. I think that's the only thing that I missed.
Set that to false. so that preview get the previous preview block relative transform, drag that out and that up like so. Let's compile, save, and go back and test this. Play, press F to change to first person view. Press F again to toggle back to third person and confirm that the preview block is in fact attached in the right location. Let's go back to the BP block player and comment this big chunk of code that we just wrote. So I'll select all of it, press C. For the comment, toggle FPV and third person view. So the next feature I think would be really useful is the ability to zoom in and out. And we'll use a couple of inputs for that as well. So click on edit, so the preview block is in fact attached in the right location. Let's go back to the BP block player and comment this big chunk of code that we just wrote. So I'll select all of it, press C. For the comment, toggle FPV and third person view. So the next feature I think would
I'll just do that.
be really useful is the ability to zoom in and out. And we'll use a couple of inputs for that as well. So click on edit and go to project settings and input again. And we'll use some action mappings for this as well. So click plus on the action mappings, and we're going to need 2 of them. So just add that second one. So the first one we'll add is zoom in, and we'll set that to the mouse wheel being rolled up. So find mouse and mouse wheel
Doesn't that
up. Now we've already got a mouse wheel up and down to select the next block. So let's add a control key modifier for that. So it'll be
Got it.
control mouse wheel up to zoom in, and we'll add the control key modifier for the zoom out as well. So that'll be control key mouse wheel down to zoom out. And let's add that right now. Zoom out and mouse wheel down. Mouse wheel down. There we go. And close out of the project settings. Now we're going to write a support function for the zooming in and out. So go to find the add function button, select it, and name this get min spring arm length. And the reason we're writing this is we want the spring arm to only get so short when we're in third person view. If we let it get down to 0, it'll be squashed up in the player and it won't look good. So we'll just get to figure out if we're in first person or third person view, we'll just check if the mesh is visible or not. Drag the mesh out and drag off of it and type in is visible. And we'll need a branch, hold down the B key, and that will be the condition. So if the mesh is visible, we're in third person view. We'll make 2 return nodes. So select the get min spring arm length and add an output. And that is going to be the min length, and that will be a float. So if the mesh is visible, we'll return 100 and just duplicate that node. Oh, I didn't take my value there. 100, enter. Go. And if it's not visible, we're in first person mode, we'll let the spring arm get all the way down to 0. Now, one other change we're going to make here is we won't make it so that you actually have to call the function. You will call the function, but you won't have to execute the function. We'll make the function pure so we can just retrieve the value from it. And you'll see the difference in just a second. This is pretty handy if you're just retrieving a value. So go back to the event graph and let's start writing the code to zoom in and zoom out. So we're going to need our 2 input actions. We'll get the zoom in. And since these are closely related, we'll get the zoom out and put that right below it. In fact, we're going to kind of write both of these at the same time. So we'll get the spring arm, and from that, we'll get the target arm length. And when the player zooms in, we'll reduce the length by 20. So drag off of that, minus float, and reduce it by 20. And when we zoom out, we'll increase the length by 20. So again, off of the target arm length, type in plus float, and set that to 20. Now we'll use the get min spring arm length function that we just wrote, that right in the middle of them. And notice again, now this is a pure function so that we don't have to actually run the execution wire through it. It'll just run whenever we need the value of it. And you can see the difference here. I'll toggle the pure function. That's what it looks like if it's not pure. So since it's not modifying anything and it's just getting a value, it's handy to be able to do that. Then what we'll do is we'll clamp this float value. So we'll drag off of that, search for clamp, and clamp float. And the value is going to be between the minimum spring arm length and 1500. That'll be the maximum value that will allow the zoom out to go. You can set that to more if you like, but I think when you try it, you'll find that 1500 is a good value. Let's duplicate this, and we'll hook up the minimum again, and we'll hook up the plus 20 to that. And again, we'll clamp that at 1500. So the minimum values, whatever that returns, and 1500. And finally, we'll get the spring arm again, and we will set the target arm length. Set the target arm length to the new value returned from that clamp node. And we'll duplicate that. Make sure you hook up the target, the value from the clamp, and when we zoom out, we'll hook that up. Neaten that up a little bit. And put a comma.
Oh, Salvatore, hey, how you doing? Hope you are well. I'm here, surviving-ish for now. Just a little higher up there, maybe. Feel that? Yeah. For me, it's just I still need a job. Desperately need income. The job market sucks. But, yeah. Same? Yeah. It's awful right now. I am submitting many. Got 16 days, just puts you on playing back to. Oh! Oh. That sort of need a job, yeah. Claws crossed, you find something. Need to find something now, yeah. That's a point where it's just like, go out, get anything you can. Hit up work placement programs, grocery stores, construction, anything. I'm getting close to that point myself. Very close. Just any sort of odd job. So it might not be the field that I want or that you want, but it's at least income. I don't like that, but I can't think of a better way to do it, so I really don't like that this overlaps with that. I could do this. There's no clean way to do that. Oh, whatever. Yeah. Figuring out good formats for things will come with time. Definitely don't like that. But
Comment around it. Zoom camera in and out. Let's test it out. I declared that it worked when I put the comment around it, but I didn't really test it. Let's try it out. So we'll come back in the editor, press play, and I'll hold down the control key and roll the mouse wheel back towards me, and I'm zooming out. The mouse wheel in, and you can see you can get fairly close. That's 100 units away. That's probably close enough. You can edit it if you like or change it. And you'll see that the adding block functionality still works. And when we toggle first person view, we can again zoom out and zoom in as well. So that works. All right, so we successfully added the zoom camera in and out. In this module, we implemented the preview block as a visual indicator of what the current build block is. We added the ability to toggle between third-person view and first-person view, and also added the ability to zoom the camera in and out.
interesting.
Well,
Well, congratulations. You built a block game that's fun to play, but maybe even more importantly, you've now got the knowledge you need to expand the game and take it to the next level. Before we wrap things up, let's add a few more blocks, and I'll also demonstrate how some specialty blocks can be added. Hopefully this will pique your interest and you'll come up with some ideas of your own. And then we'll wrap it up and I'll throw a few suggestions out there for some future expansion. So to make things interesting, let's add some new blocks to the game. And we'll do that by going to the Blueprints folder and then going into the Blocks folder. And we will right-click on the BP base block and select Create Child Blueprint class and type in the name of this block, which is going to be a purple block, and it'll be BP_purple block. Now we're going to use a different mesh this time, and we'll be using a mesh from the Learning Kit. And there's a bunch of great content in this Learning Kit folder. I encourage you to explore it and make use of it. I think you'll find some great stuff in there that you can add to the game. So we'll go to the block mesh and we're going to change out the static mesh this time. And we'll type in puzzle to find the puzzle cube A. There's also a sphere, and that makes for a pretty interesting block as well. I'll encourage you again to try that out later. So that is a purple material, and there's other materials which we'll use in just a second. So let's click compile and save on that. And for the next block, instead of making a child class of the BP base block, we'll duplicate the BP_purple block. So select the BP_purple block, hit Control W, and name this one BP_gold block. Now we're only going to change the material, and I'll talk about this in just a second when we open it. So go ahead and open it for editing, and the first thing you'll notice is that we don't get the full blueprint editor, and that trips people up sometimes.
I did.
To fix that, click on the Open Full Blueprint Editor, and then we'll be back in our familiar surroundings here with the event graph construction script and viewport. Go to the viewport, select the block mesh, and now we're just going to change the material. So click on the material and select MI Puzzle Cube A2, which is a Puzzle Cube A2, which is a gold material. There's other ways to do this. We can make a single blueprint with several different colors and provide a way to change it. I'll leave that up to you if you want to try that out. In fact, I'm going to throw a bunch of ideas out later that you may try to implement. So click compile and save on the gold block, close that out, and let's duplicate the gold block. We'll select it, press Control W, and we'll call this one the BP_blue block, and open that up for editing, and click the Open Full Blueprint Editor. Now, because we're duplicating child classes, they've all got the same parent class, which is that BP base block, which is great. We need that. So let's go back over to the block mesh, and we'll change out the material this time for the blue material, or probably more accurately teal. And let's click compile and save, close that, and duplicate that one more time, and we'll do the BP_green block, and open that up for editing, open the full blueprint editor, click on the block mesh, and finally select the puzzle cube green color. Come over here to the viewport, make sure it looks good. It does, it looks great. Let's compile and save and close that. Now, you won't be able to use these just yet. They're created, but we haven't added them to the BP block player's all blocks array. So let's go back to the BP block player, open that up, and find the all blocks array, and we'll add 4 more array elements. So I'll click the +1, 2, 3, 4 times, and then add those new blocks that we just added. So we'll add the BP_purple block, BP_gold block, and the blue, and finally the green, which is very close to the grass block. So compile and save that. And that's all you have to do is make a child class of the BP base block, set it up in the way that makes sense for that child class, then come over to the BP block player, select the all blocks array, add the elements by the default values, and then you can come back and click play. And I'm going to roll up to the previous block, so I'm going in reverse order, and those blocks are now available to you to use in your game. So there's our purple, the gold, blue, and finally the green block. Now the next block that I'm going to add isn't actually a cube. So let's go back to the blocks folder, right click on the BP base block, select create child blueprint class, and this will be a BP_random flower block. Not only will this block not be a cube, but it will be a random static mesh. So open that up for editing. And then for the block mesh, Let's come over to the static mesh settings and type in flower, and we'll select the flower daisy 01. And you'll notice that that's not quite the right size. We'll fix that in just a second. We also want to fix the location of it because it's located in the center of the cube. So X and Y of 50 is good, but for the Z axis, let's put that at 0. And notice that the point of origin of that mesh is down at the base of it. So if we scale it up, which we'll do in just a second, it will grow appropriately. So for that, we're going to make sure that the block is set on scale. And I'm going to scale this up by 3.55, which I happen to know is a good size for this. And that will make a mesh that has a flower in it. Now, I'm going to do this in a couple steps. We'll come back and edit this in just a minute. I'm going to compile and save this.
God dang
Go over
it.
to the BP block player, the all blocks array, click the plus sign, and then find that BP underscore random flower block. And there it is. It's added. Let's try it out, see what it looks like first. Click play. And I'll go backwards. There it is. So now we've got a block that we can use. It's actually flowers. And now what I'm going to do is come back to the BP random flower block and go to the construction script and make it so that whenever these blocks are created, they're random. So to support a random static mesh, what we'll do is we'll drag out the block mesh and we'll drag off of that and we'll type in set static mesh. And there are 3 of these flower daisies available for us to choose from. Let's hook up the construction script from the parent construction script to the set static mesh. And what we'll do is we'll use a select statement to get a random static mesh. So right click and search for select, and we'll use the select node. And to make sure that it's selecting static meshes, we'll hook up the return value to the new mesh pin, and that will turn these options into static meshes. And we need a third one because we're choosing from one of 3 of them. So click the add pin, and then let's search for those daisy static meshes. There it is, flower daisy 01. That's the one we originally had. Flower daisy 02 for the second option. And let me type in daisy. I'll narrow it down faster. Flower daisy 03 for the third option. Now the index is going to be an integer. So it'll be between 0 and 2. And to get that random integer, we'll right click and type in random int. And we're looking for random integer in range. And we'll provide the range of that. So we want values between 0 and 2 inclusive, and that will become the index. So now whenever this construction script runs, i.e. when a random flower block is placed in the level, it will randomly choose one of these meshes. Save that, come back over here to play, and try it out. And I'm getting random meshes. There we go. So I've got 3 random flowers placed down, and you can use this for any kind of mesh. I just thought the flowers were a great demonstration of that. And now we have several blocks that we can use, and we are well on our way to having a really fun game with some great options. Once again, congratulations on completing this great project. I hope you've enjoyed the journey as much as I have, and I very much appreciate the time that it's taken you to
Turns less than or equal to max. 3, 2, 1, turn. Huh. Am I just getting really bad luck? How do you debug a construction script? Huh. You debug the object. Oh, don't know how to do that.
learn and build this game. I want to throw out a couple of suggestions that you can use to explore further. You can add new materials. You can have the materials change over time. You might want to code some blocks that have certain attributes, like, for example, a block that has lights or a block that explodes after a certain amount of time and takes out blocks around it. You can add animations to the blocks. You can add additional components, such as a skeletal mesh to the block instead of a static mesh and have an animation take place inside the block. And with that said, I know I mentioned the exploding block. Maybe a saving and loading system would be a really great feature for this game, so that if you build something amazing, you can save it and restore it and show it off later. The system used to build these levels is good for small levels. I think if
I
we
see
started
what
to
I
have
did.
many thousands of these static mesh blocks in a level, it would probably slow the game down some. So perhaps looking at other ways to build or represent the blocks, perhaps instanced static meshes might be good. Perhaps there's something I haven't even thought of. Instance blocks in a level, it would the system using, you can save it and restore it and show it off later. The system used to build these levels is good for small levels. I think if we started to have many thousands of these static mesh blocks in a level, it would probably slow the game down some. So perhaps looking at other ways to build or represent the blocks, perhaps instanced static meshes might be good. Perhaps there's something I haven't even thought of. So I'm hopeful those of you who completed the training will share your creations with others and myself. I certainly look forward to hearing about people's successes with this training. Thanks for taking the time to learn and build.
Neat. Blocks that explode. Yeah. Okay. Well, that's that tutorial. This is a good one. I like that one. I think this is all just walkthrough. Yeah, this isn't going to be... Oh, that's 2 hours, too. This is just informational. I think this is a little... Physical robot system be expensive to host around when I go virtual on this particular... Train virtual robots for sumo battles, autonomous decisions. Comfort robots, guys. This might. This module covers resources associated with technology and learning kit robotics portion. Robotics. 5 hours? Holy cow! 5-hour running time. Jesus. The heck is Real Engine Learning Kit robotics portion? The first of 5 3 interactive 3D lessons been incorporated on Real Engine. Code 2 robot to use tank movements for navigation, special targets. Robot on this perform like a robot. Vacuum used in your home. Move far backwards. And communicate output actions. This communication must be accomplished using specific software language that both the student and the robotic device will understand. Students. Blueprint node. Oh wow, each of these is an hour.
Within this video, we're going to talk about all of the resources that you're going to probably want when it comes to using the Learning Kit, specifically the robotics part of it. There's quite a bit of information in here, so be sure to take notes. And also be sure to check the description below for little bookmarks so you can jump.
So, I think this could be an interesting one to go through, but I don't think that's going to be what I'm going to go through today. What is this? Helping to try inside Unreal.
Grandpa?
Alright. Developing Introduction to Common UI. This is... No, that's going to be just informational. What's my next tutorial? What am I going to do next? New feature and tool to make it easier to learn large show, bird's eye overview, repetition, lights, nanite. Alright, this is again, it's gonna be talks and demo stuff. It's not gonna. Yeah, that's something I can watch on my own time. It's not a tutorial. Talks and demo, talks and demo, talks and demo. So, useful information, but not something for right now. Bring down components of gameplay. But, you know, what is this? Breaking down components of a jam.
Hey everyone, and welcome to Components of Gameplay. In this short course, I'll be helping you become familiar with the component system inside of Unreal and how you can best leverage the flexibility to create reusable game mechanics. This course topic is inspired by one of the classic Unreal Live tutorials by Zach Parrish, where Zach covered the idea of implementing various components to manage the common aspects of a shoot-'em-up game. A lot of this was done off screen, so when I was asked by Epic the kind of content that I'd be interested to cover for a short course on this platform.
I remember watching that video. I don't know if I've actually gone through. Oh, breaking down the components of gameplay. That's that. So technically this is supposed to come after these two, but I had issues with these two. I wanted to do this tutorial, but I couldn't follow along with it. Because I couldn't find the project they were working in. So whatever this project is that they're using,
character blueprint, and we need to somehow provide the perception system the current source code for like Unreal special macros tutorial. In this tutorial next to your desired engine, you include the source code from the launcher for your engine build. Just click the drop down next to your desired engine and select the source code checkbox, then hit apply. Now back to our first problem. We'll open up Manny's character blueprint and
so it's like they don't even say what project they're doing. So I have no idea how to follow that one. And then this balancing one. I don't remember, did this follow a tutorial?
Hey everyone, and welcome to this course on balancing blueprints and C++ in game development. In this module, I'll be going through some of the concepts that we'll be looking at.
Oh, right. This one actually specifically references the previous one, the C++ for blueprints. They actually reference it, saying you should watch that one first, but I can't do that one. So I want to do this one, but I don't know how. And then this one is what's supposed to happen afterwards, but... I don't know, maybe I'll just run through this one.
I was incredibly excited to revive the topic whilst diving a little bit deeper and moving things over to C++ and taking a look at some of the exact logic behind various custom components. A very quick overview about myself. I've had experience in the games industry and also creating various experiences and applications using game engines for multiple platforms over the years. My main interest lies in gameplay mechanics and creating quick-fire prototypes, and as well as creating weekly content on YouTube and various content for courses on multiple different sites, including here directly for the Unreal Engine. I also work as a freelancer and mentor, trying to help as many new developers make an easy transition into game development. So in this course, we're going to take a fairly broad look at how components can be worked into your projects inside of Unreal. We'll be starting by taking a look at where components are already used inside of the engine, so there's some really nice examples of some very flexible components already in use within Unreal. One thing, especially for a lot of new developers or even experienced developers who may not have put too much thought into what they're really working with, is just how many things are built around a kind of component-based architecture already. We'll then be looking at some of the pros and cons of why we would use components. It isn't a one solution fits all type thing. There will be some cases where we probably want to avoid the use of components. So in line with that, we will be looking at the kind of considerations that also need to be kept in mind when working with components to balance different performance and resource considerations. We'll then be looking at some of the different types of components. There are a lot of different base component classes inside of Unreal. We'll be looking at the main ones that you see used fairly often and just covering where they kind of fit in and what they can be used for. And then when we have an understanding of the components available and the kind of use case scenarios that they may fit into, we'll begin reinforcing these concepts by creating our own custom reusable components inside of our project. And all of this will kind of wrap up quite nicely into how we can implement this directly through code, so how we can hardcode this in our own actor classes, looking at some of the syntax required to have all of these applied for every type of that class, as well as a very quick look at how we can implement the components manually on a more per object basis. So again, adding to that kind of reusability and flexibility of working with the component system. So before you dive straight into the course, just to mention that the target audience for the course, this has been created more with the intermediate programmer in mind. So we'll be expecting some familiarity with the Unreal Engine, blueprints, and the basics of writing code in both of those.
Don't know much about the C++ side yet.
With class structures, the implementation, troubleshooting your own code, and the general terminologies and familiarity with navigating around projects and the code bases.
We'll see if I'm able to follow.
Extend to things such as understanding the basic game design terminologies and structures, and also that outside of Unreal Engine as well, because we will be taking a look at a kind of loose understanding of general software engineering architecture structures and how this isn't just specifically relevant to the Unreal Engine. So by the end of this course, you'll be able to consider where components might fit into your own projects to help you speed up the development process by easily reusing these custom components for the more common mechanics in your project.
Oh, I hope this... okay, this... Component based on active first. If this is all just informational, I'll watch this on my own time.
As you're seeing, only familiar with some blue, take into account and kind of balance, which if we were the...
It's like they actually get into a project and have you follow along?
I've provided is being described when the components are being talked, a little bit more of a, and the another one based on a...
Alright, this, I don't think this is a tutorial. So... this is something I should just watch on my own time. I'm not going to just sit and watch videos on stream.
Around the parent actor to float between 2 points, so something nice and simple. But it will show us the main concepts that we're looking for when working with actor components versus scene components. So before we get started creating our class, we're just going to take a quick tour around the project that you can download to follow along with some pre-made example classes.
Okay, so I guess there is tutorial stuff. Alright, where did we leave off? I have a feeling we got like...
So before we touch any code or
30 minutes of
the Unreal Engine, the first thing to do is ensure that everyone has an understanding of the concepts and terminologies that will be used throughout the duration of the course. We'll also be looking at some of the considerations that should be kept in mind when working with components and balancing their use in your own projects. So some of this may already be familiar to people experienced with the engine, but we'll also be going through some of the lesser discussed topics. So I hope that this brief overview will provide something new for any developers. To begin, we're just going to look at the main type of components that you'll see fairly often throughout the engine and specifically in this course as well. So the first one, as pretty much with anything in the standard kind of class hierarchy, we have the actor component. Of course, in the standard class hierarchy, there's one above this, which would be the object class. But in a very similar way, this is the base class for components. We can define in here our reusable behavior, and this can be added to different types of actors. Next, we'll have our scene component. Now, these are basically actor components that have a transform, so this can be a little bit confusing, as the actor classes inside of Unreal, of course, have the implementation of transforms as well. Of course, you can place your transform in the world. In a similar way, the scene is that version of a component which has a transform, so you can place it somewhere specifically inside of your blueprint. And it also has the capability of having another component attached to it, which actor components do not allow. And then we won't be touching this one directly in the course, but this is another very useful one to know a little bit about, and that is the primitive component. So where the scene component implements the concept of transforms, also things like collision capabilities, the primitive component is just a scene component that contains or generates a kind of geometry. So you've probably seen these a lot of times implemented in some of the default classes and just may not have considered exactly what it is that you're using. With Unreal being quite as big as it is, these of course are not the only components in the engine. By no means, if we look at just, some of these are even cut off, but if we just look for the component classes that are already available to inherit from, we have a long list of different things that we can already implement and use within our own projects. So you can see here just in this bit that even though that's being cut off, there's already a lot of things which just inherit directly from the actor component alone. And again, looking at some of these, you may have already used some of them or implemented them in your own projects. Now again, before diving straight into anything, there's also some considerations to take with the components that we'll be working with. Although they can be super useful and they can definitely improve the workflow in a lot of different projects, it's also important to stress that this course is not intended to say that it is the best or only way that projects should be approached, as there are some drawbacks and costs when implementing the components. So for the positives, they are generally lighter than the counterpart, so the A-actor component versus the A-actor. The A-actor has a lot of things, if you look in the code, going on, including a lot of networking and replication calls going. So if you were considering creating separate actor classes just to house certain logic and kind of reuse that, in many cases it will be cheaper to actually do that same logic in the actor component and reuse that instead. However, saying that, as with anything else which is loaded, this will incur memory costs when these are being loaded in. So any class which is housing your actor components, your scene components, anything like that, will have that extra loading cost when you are opening your level, transitioning between maps, or spawning in new actors with those components attached. In a similar way, they also house some potential runtime implications. You always need to remember that by default, as with most actors, unless you've turned it off in your project, then you will have the update or tick functions set to be active by default. So again, the more components that you have on any one class and the more of those classes that you have in memory at runtime will all start adding up. Now, this isn't to scare you away. It's going to take a lot of kind of abuse to really make this a problem. But like I said, it's just to make sure that we don't start looking at this as the only or best way to always go forward regardless. As with anything, when programming, there will always be considerations to take into account and kind of balance the best end performance. So just as an example, very quickly, of some of the basic code you'd see in a very standard component, just to really kind of reinforce the kind of things that are happening behind the scenes, especially if you're only familiar with some blueprinting in the past. So to begin with, this is a scene component, which if we were to jump into this class would obviously be inheriting from the actor component. So this is going to be doing all of those function calls from the parent as well. This will include things like a call as well to the constructor. So as with any other C++ class, we'll be doing our variable settings and default property updates here in the constructor. We then have a call to the begin play. You can see this as an override. So again, we'll be accessing our parent's begin play function. So all of these, again, will be doing this when the level is loaded per component. So again, these are the kind of things that you want to keep in check. And then as we can see down here, we have the override call to the tick component as well. This is the component version of the tick event, which is the tick component, very similar though. And again, this is an override. So all of this will be calling the parent component and so on. And I've highlighted these functions because the constructor, begin play, and tick component are all default. I've not added these, so anytime you create one of these components, all of this will be included by default unless you come in and start removing things and customizing it to your needs. So you now know some of the distinctions between the different components that we'll be working with, some of the things to consider when working with those components in your own projects, and just some of the ways that you may already find that you've been working with some of these default components in your own projects. Working with components isn't something specific to Unreal and the Unreal component system. Many languages and applications are made with what is called a component-based architecture, and those familiar with other engines, even such as Unity, would be familiar with reusing scripts between multiple game objects to reuse those common mechanics, which is a very kind of component-based approach. For that reason, I've provided some kind of extra reading links, so we're not going to go through these in detail. This could take a course by itself, just going through what I would class as some interesting reads, existing articles, and kind of small papers on a component-based architecture. Now, the first one here is by Ray Wendelich. If we take a quick look at what this page is, there's some really nice tutorials on this kind of small paper. On a component-based architecture. Now, the first one here is by Ray Wendelich. If we take a quick look at what this page is, there's some really nice tutorials on this page in general, but this is a really interesting insight to the way that components can kind of solve and address some of the existing issues in a more inheritance-based architecture, as noted down here. And I think that's super interesting, especially when you consider just how much of the Unreal structure is based very heavily on inheritance. Now, that's not to say it's a bad thing. This is more to cast some considerations and make you think about where you can start balancing inheritance with components to get the most reworkable project, and in the long time, save yourself some time in your projects. So this is a very good read. It actually goes through the entire process of making a small game. And I think this is super useful because not only are you looking at the concepts here, you have access to the code at the bottom. As you can see, it is quite a long read, which is why I've said we're not going to go through step by step on these things. But it does provide all of the code. So this is very useful that you actually see what is being described when the components are being talked about, how they're going to change things out. And you also get to see it as the result of the end game, which again is super useful because you have that whole process and you can see exactly where these concepts come together in the pipeline of a game. So I definitely recommend this one. This is a very good read, very well written, and even though it's not Unreal related, the kind of comparisons between inheritance and where components can really free up the development pipeline is very, very interesting here. So the next one, you probably saw that I have 3 tabs open over there. So we have the decoupling patterns, which is on gameprogrammingpatterns.com. So this one is a little bit more of a shorter read, which is quite nice. Again, you've got some code examples here. This one's quite nice again because the code is provided. It gives some examples of when you would want to use this kind of thing. It also has a kind of more structure-based approach as well in the writing. And then this is a very similar kind of language to what you would see inside of Unreal anyway, C-based language. So a lot of the syntax here is going to be very familiar, and you can see how something, again, outside of Unreal would fit in the same kind of concepts. Much shorter read, so again, definitely recommend going through this one. And the final one that I would recommend reading through, the component-based core game engine architecture. So this is what I'd class, I suppose, as a very small paper, which is written for someone's portfolio page. But again, some really interesting insights on this when I was reading through it.
Ah, botched it. What did I miss? Character Mars D6, let's go. Yeah, I went through another. Well, I finished another tutorial already, and I'm starting this one. I'm not sure it's gonna be something I can. Oh, that's what I did. No. Yeah, not me. Some of the things they said, like who it's intended for, might not quite be my level yet, but also I would very much wanted to do this one. Where is it? 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 Every language show. Dude, okay, something is missing. Here, this is what I was looking for. I wanted to do this one. But I can't find the project file, and they don't suggest where to get it. It's just they just start working with it. And it's like that's not helpful to me. But yeah, the C++ for blueprints. I really wanted to go through this. I kind of watched it, but it's really hard for me to follow things when I can't follow them. But yeah, they're in this like Manny project or something. They have this character that's looking around or something. I don't know what this is, but they're working with that. And I don't know what it is.
Written C++ based
So
produces to automatically
turns out Unity and Unreal docs are two sides of the same coin. A lot of the tutorials have been really good, but there's been a couple that's like, okay, this isn't so different. But yeah. But the C++ for blueprinters is what I want to do. And this balancing blueprints for C++ in game development, I want to do that one as well, but it specifically references the C++ for blueprinters and says you should do that one first. So I was like, eh. So I skipped down to this breaking down components of gameplay. That's the one I'm trying to see if I can get through right now. We'll see. But yeah. Oh, crud! No. Oh, that is pretty burned. I burned my lunch a little bit. I got distracted. I thought the timer was set just a slightly bit too long. So AFK a minute. Okay. Oh, right. I was trying to get this link. Yeah. Okay. Prometheus. Actually, first things first. That's like full on the site's gone, so instead of just going for the URL. GESSESHABRIO. Okay, yeah, this is just straight up the site's gone. Okay, so not doing that one.
And what we have here is another article written. This is using C++. We have some nice examples here using kind of UML diagrams to see where things and kind of really visualize where things might come into causing a restriction, and then when the code and components are going to essentially address this. So this is another one based on a very kind of simple game or game engine. Again, it's in C++, which means the code is going to be very relevant to what we're going to be doing. And it does show some really nice, very simple, very much refined kind of examples of components in a more kind of native C++ approach here. So this is one thing I would mention though, is all of the ones that I found at least that were very interesting for me to read through and kind of track down to provide for this section. All of these have ended up being game engine related, to the point I think most of them, apart from Cocoa, are C or C++. The one thing I would say is definitely take a look around, look through some search results for a component-based architecture, and see if you find anything interesting as well to dive into where this kind of thing is used a little bit more outside of game engines and game design, because it isn't just restricted to those kinds of development environments. So we've just taken a brief look at some of the options to learn more about component-based architecture in more generic development structures for people who might be interested to learn more about the topic. We're going to be taking a quick look at just some of the gaps the use of components can fill in a more traditional game development pipeline, especially those seen inside of Unreal. Due to the prominence and inheritance-based class structure inside of Unreal, you find that many projects end up relying heavily on inheritance and polymorphism in the project structure. And whilst there's nothing inherently wrong with this, there are some scenarios where it can become somewhat restrictive. So let's take a look at a really simple example, but something that can quickly get out of control if not accounted for early in the development pipeline. In this case, I'm considering a very simple game like an old 2D Zelda RPG, but I've picked this because it can also have some very kind of wide and flexible systems implemented. In this type of game, when traversing the world, the A button can usually be used to interact with a range of actors. For instance, we can walk up to a chest or item lying around on the floor, and you can press A and you'll be able to interact with the item and either open the chest or collect the item. We could also walk up to an NPC and engage in some dialogue with them if we press the same interact button, and in rare cases we may even encounter an enemy that doesn't dive straight into combat and interact with them in a similar way. All of this can also extend to set dressing like trees, rocks, and other points of interest. And if you have a system in your game which is flexible enough that's implemented in this way, this will allow you to very easily add kind of flavor text to the game to provide funny kind of quips when you're trying to interact with rocks or providing extra information about the type of shrub or tree that you're looking at and just how that fits into the world's lore. So let's take a look at what the inheritance approach might look like if we tried sticking perhaps with a somewhat too stringent use of utilizing inheritance and cutting down the code duplication. So we could have something like an interactive base class with our interact functionality defined. From this, we could split into more object-focused classes, which would make up the set dressing and pickup items. And then going down the other path, we could have our interactive pawn class, which would be the base for our players, NPCs, and enemies. Now, at the moment, this doesn't look too bad. It could definitely work, but it does look a little bit strange when we read back through our code and consider that a door and an NPC are both inheriting from the same custom parent. We can even end up with a less ideal scenario. I've actually come across projects that look somewhat like this, where reusability was a focus, but hadn't been fully considered early in the project. This can lead to situations where you might take a fairly common class, such as the pawn, implement your interactive function as you've only foresaw it being used on enemies and NPCs, and then later you realize that trees and chests are really doing the same thing. In this case, a tree could end up as an NPC with features such as dialogue trees, inventory, health, animation, and the like, all stripped out, which can definitely be a little bit of a strange way to...
Trees can have inventory!
And this is going to be more familiar, hopefully. But a quick look at our class structures and how they might look in a project without these restrictions imposed. Our pawn structure would be much more refined, composed purely of the NPC and the enemy subclasses, and that could potentially have a boss subclass as well. And these would have the properties and functions specific to those types of actors in the game. Likewise, the objects can take their core features and be separated based on those things relevant to them, like being a static object that would consist of the set dressing, like trees and rocks, and then collectibles, such as the items and chests. Then with the use of components, we'd create a flexible interact component, which we can then apply to the required classes, ideally the base pawn and the base object class, so that anything that derives from these can then support some type of interaction. And approaches like this allow for the potential for some emergent gameplay moments coming from a wide range of flexible systems all working together in sometimes fun and unexpected ways. So inside of our interact component, we could implement an onInteract start and an onInteract end function to allow classes like the enemy class to launch into combat on interact end, or collectibles to be removed and added to the inventory. Alternatively, things like a Boolean check, like a multi-interaction check, will allow the chest to only be opened that once and then never reused, whilst NPCs will be able to repeat their line of dialogue indefinitely. So this is a little bit of an abstract example for the use of components, but I wanted to demonstrate that they don't always need to be something to manage the type of something or the movement of an actor, or doing things like variable trackings in the health components and things like that. Now, these are all going to be examples that we will see and make use of in this course, and that's why I wanted to take this slightly larger, more abstract version of a component class and another way that it could be used. So now that we've seen some of the considerations to make when working with your components in the previous section and the benefits of using them in this module, we're primed and ready to take our first look at how to create our own custom components and begin adding them to an existing actor. We've now seen a lot of information about components, how and why they can be used, so we're now going to create and use our first custom component. This will be an actor component that will allow the parent actor to float between 2 points, so something nice and simple, but it will show us the main concepts that we're looking for when working with actor components versus scene components. So before we get started creating our class, we're just going to take a quick tour around the project that you can download to follow along with some pre-made example classes. In the main map, we have a few different actors with the destruction components attached to demonstrate the different outcomes. We also have in the content browser some different effects and a default mesh. And then finally, we have a demo actor blueprint, which is simply a child of the demo actor C++ class. This is just an empty class with an interface attached, ready for us to test how we can add our custom components to later. So we'll be using all of these later in the course, so you don't need to worry about or be concerned with these right now. Just know that they're there, and if you did want to look at them between the different videos, then they are fully implemented and you can take a look at what they're doing, but we will be covering those all in time. So to get started, we can create a new C++ class of type actor component, and
Why is it that it never seems to update this properly? It's like even coming straight through here. Did it not add it? I clicked the thing. Wait, okay, why is it not? Oh, compatible in it, wow. Oh, this is only for, okay, 4.26, I see, I have to install a whole new. Man, I just keep going down and down and down on my current version. 4.26. This will be interesting, because I've never done anything with 4, so we'll see how different 4 is, I guess. But really, this is going to be basic overview concepts that I'm sure will translate just fine into 5, so. Oh, I messed up. I mean, it probably has options that I need to have disabled. 4.26. I won't. How do I set the options? Oh, fine, whatever. But I don't remember seeing it. Oh, whatever. Interesting. I'm going to guess that this was with 4.25. Wait, what? Why are you not working? That's blueprint to make sure. 4.26, 4.25, 4.27, show breakthrough, show. Well, that's annoying. Alright, there is a small possibility that this might be something on my side. Give me a minute. I am somewhat getting low on disk space on that drive. So we are going to see if bringing up some disk space might help. Character Mars, you goofed. Is this the resource you shared with me on D3? Just have someone else post it on the most dystopian social net. Oh, LinkedIn! If it isn't, thought you'd share. Let's find out. Is this one that I've already done? Unreal Engine for you. Whoa! Unreal Engine for Unity developers. No, I don't think I've seen this one. If you want to switch from Unity to this section serves to outline the familiar. I was looking for something like this. I specifically was looking for an Unreal Engine to, or a Unity to Unreal Engine, and I didn't see one. Start by reading the Unity to Unreal overview. Dude, this is great. Thank you for linking this. I did not link this, so this is nice. Indeed. Thank you very much. If you're moving from Unity to Unreal, it could be challenging to translate familiar features in whatever language. While both engines have similar functionality in many cases, use ecosystem and the way it is organized differ from Unity in many ways. Yeah, no kidding. Definitely have figured that out. This guide provides a walkthrough of essential Unity editor features and concepts and their Unreal Engine equivalents. Section below review the following topics: managing projects installation, navigating the Unreal Editor, managing level files, translating Unity game objects, terms and operations in the Unity Engine actor framework. Okay. Unreal Engine 5, Unity 6. Or file no, okay, file transfer is still going. So, since we're waiting on this file transfer anyway, let's go through this. Epic Game Launcher is Epic's equivalent to Unity Hub. I am not the best at reading out loud, so I'm probably gonna skim these instead of trying to read everything out loud. Click the Unreal Engine tab. Set a launcher. Click the library. Yeah, okay, that stuff I already know. If you want an offline installation, download the source. Nice. Installing. Unreal Editor is an application for editing UE levels and assets. Screenshot below shows Unity Editor and Unreal Editor side by side. Different areas colored to indicate common functionality. Each block is labeled to show equivalent Unreal Editor terminology. Okay, that's cool. This is really neat. Oh, seriously? Open image, a new tab. Oh wow, you suck. Fine. I was trying to get a bigger view of it. So toolbar, main menu, play, pause, step controls, play and editor controls, hierarchies, outliner. I don't have a version of Unreal open at the moment. Scene view, game view, viewport, inspectors, details panel, project panels, content browser. Okay, console is output log. Yeah. So I pretty much had started to figure these out, but this would have been invaluable information from day one. I wish I'd had. Newsletter is fully customizable. You could drop tabs, documents, see customizing your own. Okay, I have some idea of those, so yeah. File, edit, assets. Functionalizing the content browser, okay. Game object is an actor. Component is a component. Services is online subsystem. Menu for accessing Unity's cloud services. Unreal's equivalent. Package manager is plugins, which is located in edit. Many online subsystems are available as plugins. Okay. Tools, build, and select. Provides character markers. Okie dokie. Thanks for the lurk. Do take care. And thank you for the link. Oh my gosh, this is amazing. Provides access to various different toolsets, menus, including debuggers, shortcuts to creating C++ code in your IDE, revision, control options, and more. Okay. It's options for building different features. Select tools for selection management in the level editor. Unity places these in the edit menu. Includes options to select different types of objects. Okay. Window, help, blah, blah, blah. Different areas of okay. So transform gizmos, yep. Those were there to now we're there. Local world space controls. Yep. Grid snapping controls. Lighting and shading. Perspective ortho. They're way over there now. Object channel visibility and camera settings, okay. Project panel content browser. Content browser center is equivalent to project panel. You can browse and create the game assets as well as click and drag them into your viewport. That's what I figured out. Inspector details panel, yep. Project settings. Oh, good. File transfer finished. Let's see if we can get this to work now. Bring it on now. Can't be reached. I've got 69.8 gigs free. Nice. So it's probably not a file size problem. Only other thing I could think of is we try and install yet another version, 4.2.5. 4.2.5. There's no options. Interesting. There's the options. Okay. Start a content template. That's fine. We get rid of all this. I don't care about you. I don't remember. I don't think they needed that. I don't remember though. All right. So yeah, we'll let that do its thing while we continue reading this stuff. Edit plugins. Plugins are enabled. Disable many plugins. Beta features. Plugin is the plugin menu is compatible with your current version. Neat. Scenes and levels. Level files are Unreal's equivalent to Unity's scene files. Okay, pretty much think I've figured that one out. Much like Unity's scenes, you can load and unload these synchronously or asynchronously, while you can hard switch to a map using the open map function. Unreal's world partition system can automatically stream levels based on a player's location. Yeah, I saw reference to this, and I'm really eager to learn more about it. That seems pretty cool. Scene templates and world settings. Whereas Unity Store uses scene templates to set up common objects or frameworks between multiple scenes, Unity engine levels have built-in world settings, which provides a place to override its game mode settings to change its settings. You can use game framework classes like a game mode, U game instance, and a game state to create additional logic that you can. Okay, we've touched a little bit on this before, so I have some idea. Picking your default level. Okay, we've gone over this for sure. That's just that. Game objects, actors. Actors are Unreal Engine's equivalent to game objects. I thought so, but I hadn't gotten a confirmation on that. Whereas Unity uses a composition-based framework for building game objects, Unreal uses a combination of composition and object-oriented approaches. Yeah, this has thrown me a little bit for a loop. prefabs, blueprint, and C++ classes. This has also been a sore point. In a real engine, instead of creating actors in the world and then saving them as prefabs, you create a new actor class in C++ or Blueprint, then add instances of it to your world. When you create a new actor, you can choose to base it on another actor and inherit all of its components and code. If you prefer Unity's workflow to editing game objects and prefabs, you can still place an empty actor in the world and then add components to it. After that, you click Edit Blueprint button and convert object to a new blueprint class. Interesting. I have to figure out how to do that. It doesn't seem like that's something that I want to get in the habit of doing, but it might help me better understand and really solidify my grasp. Placing and browsing actors. Browse UE's library pre-made commonly used actors. Place actor panel. This is basically the add button, I think. Oh, that's the there's a little button at the top of the show. Primitives, click and drag actors in your viewport to show. Okay. You can also use the actor, place actors drop down in the main menu to come shown. The menu is also available with right click in your viewport. You can also use content browser. Components. I was just starting to try and learn more about these. Actor components and scene components are Unreal's equivalent Unreal's engine's equivalent to Unity components. Scene components have relative transform and appear in the actor's component hierarchy in both Blueprint Editor and the Level Editor's Details panel. Example of scene components include meshes, audio sources, cameras, particle system, lights, or anything else that benefits from having a physical presence in the game world. Actor components have only code. They do not have a transform or physical representation in the game world. Examples of actor components include movement components or components for handling AI, such as AI sensing component. That sounds like it could be fun. AI blackboard, AI behavior tree. I want to get into all of this stuff. So much fun. Many of these can interact with the world, but they don't need a local transform or their own to do it, instead relying on their own parent actor to determine the world location. This is like what it equates directly to Unity's components. Playing screenshot is top-down character from the top-down game template. Scene components are parented under the actor and include the actor's mesh camera collision. The character movement component is an act. Oh, okay. This is like a sudden light bulb of now makes more sense. This is effectively the game object hierarchy, and these are the components on, I guess, this. But curious how you'd add components to this. Interesting. It's a dim light bulb. It's not complete, but it's getting there. Add components to an actor in the game world by clicking the plus add buttons. Yeah, okay, know that. Add components directly to a blueprint, pressing the add button. Blueprint. There's component. Oh yeah, okay, yeah, we've done that. Object create default subobject. If a component should be attached. This is a little beyond me at the moment. Parenting game objects, sub-objects in Unreal Engine. Okay, we'll get to that in just a minute. We want to go back and check our status here. Let's check our disk space. 52 gigs. Okay, create new project. Actually, let's do this. Oh, I meant to hit cancel, but that's fine. How do I delete? Alright, sure, fine. Component project. Oh yeah, because it did it in the folder that I really don't want it to be in. We're really gonna have to figure out how to delete stuff. 425. 425. Not be large. Okay. Well, aren't you annoying? Project names must. Oh, that's the name. 425. Directory must not be empty. It's not empty. What? Wow, you don't like me having a underscore there? No, okay, no, that's weird. There. 425 create. Okay. Yes. Yes. Okay, following modules are missing or built with different engine version components of gameplay. Modules are, I must be missing something. Components of gameplay. I don't know. I don't know what that means. Options. Missing components. Hey Eric, how you doing?
Haruk fattened 1 Chris's. Newt Newt. I went to a silent auction. I won a dog whistle and 2 mimes.
God dang it. Silly Eric. You know, I really hate that. Oh wait, no, wait, why is it? Okay, I don't know what's going on. Component of gameplay. I recommend breaking down the components of gameplay. But why is it? I don't understand. Check out the Understand. Duplication.
Haruk fattened 1 Chris's. Newt Newt. I went to a silent auction. I won a dog whistle and 2 mimes.
Doing alright, glad to hear. Check out the Understand component of show.
And notice here there's a quick recap on. And finally, we have created.
Okay. What am I
A
missing?
lot of information about components, how and why they can be used. So we're now going to create and use our first custom component. This will be an actor component that will allow the parent.
Alright, call the ISP fellows. Apparently they won't call your old ISP for your old deal before they have confirmed that you got their router up and running. Huh. And you're still waiting on the router?
Float between 2 points, so something nice and simple. But it will show us the main concepts that we're looking for when working with actor components versus scene components. So before we get started creating our class, we're just going to take a quick
Sorry, Eric.
tour around the project that you can download to follow along with some pre-made example classes. In the main map, we have a few different.
I'm trying to download and follow, but you're not letting me. I don't know what's... At least you still got your old internet till that's good at least, yeah. 7 comments. There's comments, okay. Senior actor, which give me a minute. Okay, I cannot figure out why this doesn't load. I don't know what I'm missing. Following modules are missing or built with a different engine version. Components of gameplay. I think that that's what this is. This is probably this module. But it says it's compatible with 4.2.5. But when I try... Bringing down a channel could not be compiled. Try rebuilding the source from manual. I don't know how to do that. So we might not even be able to follow this tutorial either, which is super frustrating. I keep coming across tutorials that I can't follow, and it's like, these would be good, but I don't know what to do. It's like, you know, if a tutorial's not working, I'm trying to learn stuff. I don't know enough to fix things because I'm trying to learn them. So it's like super frustrating. Well, I guess we go back to reading through this. Parenting game objects, sub-objects in Unreal Engine. Unity to create complex objects, multiple parts that have relative transforms. You need to attach game objects to children to game objects. Unreal, you add sub-objects by adding scene components to your actor. Scene components fulfill most jobs that child game objects do in Unity, such as providing colliders, particle effects, audio source. Okay. I'd started to pick up on that. This would have been useful information earlier. You can also use child actor component to attach an entire actor to another, or you can use attach actor function in your code to do it at runtime. Yeah, we encountered this briefly. Gameplay framework is a collection of classes. Pick and choose which elements are right for your game. Building and packaging. Yeah, I'm not ready for that, but I get the basics. Okay, so we now have gone over what they referenced here. Never used internet start which maps key terms. Yeah, that would have been super useful. I'm going to share pages below to learn how to migrate from Unity to Untitled. Oh my gosh. Coding blueprints versus C++. Okay. So it looks like we have some paths to go over. Unity to Unreal Engine overview. If you're moving this... Wait, is that? That's the same thing. Why did they link it twice? Okay, we just went over that. We don't need to go again. Oh my goodness. Unreal asset type. Static mesh is a mesh. Okay. Skeletal mesh is a skin mesh. Okay. Animation mechanism. Texture, audio. Video, fonts. Speed tree. I never worked with those. As a consideration before input, Unreal Engines, Unreal Engine, Cartesian, represent straight image, coordinate system is left-handed, use XS. Isn't this the same as? It's also left-handed, whoever uses X. Represent left and right, Y to present. Yeah, I thought that was backwards, but my brain just automatically flipped it and couldn't remember because I have had to flip that logic in my head enough times that it just flipping that comes naturally. That which one is Y or which one is Z is you're up. This is when you're directly importing it. So obviously you could change the assets orientation inside digital content. Okay, yeah, I'm not so much worried about that. We'll figure that out later. specific language, yeah. 1 Unreal is equivalent to 1 centimeter. You know, 1 meter. Yeah. Unity's default is 1 meter. So effect scale. Can remember now. Unreal Engine supports a variety of file formats. One of the most popular is SFBX. That's going to be the same for Unreal and Unity. Time this writing, preparing to export assets from Unity. For export asset files. Export package manager. Oh, okay. FPS exporter, but if I've already got the FBX files, that's fine. I don't need those. Meshes, static meshes. Static meshes, 3D meshes. Geometry do not change. You can import static meshes under the FBX or object runs. This example has 1 mesh and 3 materials. However, your mesh prefab can contain multiple meshes. Import static mesh. I feel like this is going to be much more relevant a bit later. Character animations are built using skeleton mesh animations applied to Unreal Engine provides a variety of animation tools. Skeleton. Okay. Export to FBX essays, yeah. Importing animations, now we get import mesh, you just check that off. Yeah. Yeah. Huh. Convert scene properties. What is this? As a pipeline original, you can enable convert scene, force front access, and convert scene Unity properties correctly. Correct any broken or irregular meshes during playback and renew these properties. Reimport base. Convert scene unit. They're so used to typing Unity, they type unit. It's supposed to be just unit. I don't know what that is. Simultaneously editing multiple assets. Animation blueprints. Done a little bit of this. Textures, exporting texture from Unity, importing texture into Unreal. Shaders, materials, they have their own effectively shader graph thing. Particle effects, Niagara, VFX. Unity's visual effects use great GPU particle simulation system, uses node-based interface to create a channel. Niagara system uses Office full control change programmable. Yeah, this diagram system is pretty cool. Yeah, the audio system is really neat too. Meta sound is pretty cool. Export audio, import audio, video. Not messing with that at the moment. And here comes the several tools to create cinematic content timeline tool. Use to create cinematic sequence in Cinemachine for tools for controlling the camera. I've used these extensively in Unity. Work together these tools. Sequencer in Unreal's multi-track editor, creating previewing cinematic sequence. The editor contains robust cinematic tools. Pilot cameras, level 5-throughs, image. Okay, so sequencer is more about cinematics and sequencer. In this case, you'll have to recreate the image. Camera animations, behaviors created in timelines. That's to be expected. Code and visual scripting. Big difference. Big difference. Wow. To completely set something as inactive, you have to do all of that. Interesting. Unity default. They did just pick something that's a little more complicated though, because there are some other things that in Unreal is ridiculously simpler than in Unity. Unity also has Bolt, which is Bolt cannot be yes. Any gameplay and what the heck? What? That's weird. EDCO. Huh. Interesting. Hey Trevor, how you doing? What is that? The stinks. Hope you're doing well, Trevor. 2D assets. Paper 2D is a sprite-based system for creating 2D. Okay, Paper 2D system uses texture files, map to a planar. I'm not gonna do a whole lot with 2D, I think, but yeah, that's exporting, importing. I'm not gonna worry about that. And speed trees. Okay. Hello, you're new. I'm sure you are. Wobble, 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 wobble. Okay, that's interesting. So we've done that. Introducing to rendering. This I don't think is going to be up my alley yet. Uniforms, fresh, yeah. So like I never dealt with heavy rendering stuff. So Unity's rendering pipeline performs similar steps when it does steps, draw calls. So I'm not going to get into too much deep of this. Did a thing, probably like a lot of shit. Is there noms involved? Rendering texture, pixel shaders, Unity's equivalent, pre-built. Shaders equivalent to materials. Okay, so shaders are materials. I kind of figured that. Which is interesting that materials aren't materials. Get my head around that. Here comes yep, shader graph. Unreal's Engine Material Editor. Worked with that. Reflections. Okay. Dynamic lighting. And light in real-time global. Yep. Trevor likely. It's lineage, post-processing effects. Okay. Yeah, like I said, that's a little not quite where I'm going to show. Where we coding in E. This is going to be a big one. Blueprints versus C++. You can make Unreal Engine project using only blueprints, or C++ projects benefit from using a mix. Yep. So just program versus scripting. To best know when you use you must understand the difference. Programming instructions, scripting instructions, define behavior by interacting. In this context, C++ is a programming language, Blueprint is a scripting language. That makes sense. However, it's not a clear distinction, as you can use C++ to define behaviors or use blueprints to define systems. Additionally, there are times of projects where the line between programming and scripting is blurred, and the best split between the two depends on the scenario. Blueprint functions as a scripting language by interfacing with exposed UI functionality. Likewise, you can expose your custom functionality to blueprints. Combining blueprints. Is this one of the ones that we were trying to go through? I'll figure that one out later. Because every project and team is unique, there's no right choice. Blueprint strengths. Blueprints can be more easily defined behaviors. Blueprint is excellent for prototyping. It's quicker to create, modify, compile, and test blueprint classes. Blueprint's visual flow representation is easier to understand and use. Debatable, but I could see that. Being accessible to visually oriented programmers or non-programmers like designers and artists. Absolutely can agree with that. Greater discoverability with blueprints, easier to find and include API and asset references. Definitely can agree with that. Safer memory model. Interesting, because I was under the impression that even their C++ version still had a lot of memory safe stuff. But still. C++ strength. C++ can more easily build new systems. Makes sense. C++ is more performant, but the significance depends on the context. Yep. That is absolutely true. C++ has access to lower level UI functionality. With C++, you can create interfaces and external systems and libraries. Okay. C++ grants low-level control over systems, resource complex algorithms. C++ is stored as text, making it easier to diff, merge, and share between projects. Yes. However, you can still use the Unreal Diff tool with blueprints. Very interesting. Large C++ files are easier to modify than blueprint graphs. I definitely could see that. There are more powerful debugging tools C++ than Blueprint Debugger. Now, Trevor, what all do you know about coding? That's a broad question. I mean, I've been a software engineer for 20 plus years. Enterprise developer, specifically with Java, for 8 years, give or take. Dealt a lot with PHP, like not just script kiddie PHP, but proper framework and OOP PHP. It's like, that's a very broad question. Combining blueprints. I'll give you a cut of your game if you help me fix your lobby codes. What engine are you using, and what do you mean by fix your lobby codes? Expose C++ to blueprint the following show. Best approach to combine blueprint and C++. Use C++ as foundation and blueprint on top of it. In practice, this means exposing a C++ to be usable from blueprint. You can expose C++ to blueprints with the following methods. Create a blueprint class that extends C++ using metadata specifiers. Okay, yeah, we went over those. Some less common cases you want to expose blueprints to C++, which you may do with the following methods. Okay. Haven't encountered that, but that's probably because of the tutorials that I can't do. Frustrating. More information, C++ blueprint, exposing C++, okay. Trevor, Unity, okay, I'm much more familiar with Unity. That was weird. My headset just decided to shut off. Creating a multiplayer Steam game using Rizzy Steamworks and Mirror Networking. I haven't worked on it in like 6 months, but it still works. I haven't used either of those two technologies. I've used Unity's netcode, so network objects. That's what I did for Whimsel. And that had a, I mean, let's see if I can get it to work. So this has multiplayer, and you can start a multiplayer, get a code, and join based off of the code. So kind of similar, but probably different. Let me see. Let's see. The Unity projects. Whimsel. That's the WebGL build. Where's the Windows build? Strange. I have to show you sometime. Sort of gave up on it text because you know it's. I'm not gonna say anything one way or the other on that. I've had enough. I don't subscribe to that anymore. I have lots and lots of ideas. So many ideas. I also have had many ideas that I've seen others do, and it's like, man, I had that idea like 5 years earlier. I just wasn't able to do it. It's like, didn't have the resources. Yeah. They were showing in progress. Well, you're more than welcome to share when you would like. And yeah, just that's up. It's up to you. Just message me sometime. It sounds like you wouldn't want to do it while I'm on stream, which is totally fine. So you just have to catch me when I'm off stream sometime. But yeah, happy to try and go over stuff and see if I can help you figure out where the issue is. It is, like you said, using some frameworks that I don't know, but it might just be something that can. Sometimes just that other pair of eyes can help. Yeah, not really in a rush. Been sitting on this for 15 years. Yeah. Yep. I feel that one. I have been using Unity. Oh, Jesus. I don't know. Probably about 15 years. Have lots of ideas. Actually, just recently, so I haven't really been great at keeping all of my notes in one place. So I had notes scattered all over the place. Like, I'll come up with an idea and I'll start jotting it down. It's like, oh, this could tie in with that, and this works this way. So I have all this, I have so many notes, and I have like, how many white ones? 1, 2, how many do I actually have here? two, three. I have 6 whiteboards behind me. And like pages on actual paper, but a lot of file content, just like notepad files and stuff like that, scattered all over the place. And I finally started compiling everything together and putting them all into one place, so that I could more organize my thoughts, because it's very scattered. And I finally did that. And then I put it into a Word document just out of curiosity to see how big it was, and I have over 100 pages of notes. It's like, oh, I didn't think I had that many notes. I knew I had a lot of notes. I didn't think I had 100 pages of notes. It's like, yeah, so I get the idea of, like, yeah, I've got ideas that have been ongoing for 15 plus years. Yep, I get it. Yeah. Yeah, we'll talk now. Oh, I read that. Yeah, just message me, hit me up. Thursdays are the worst day for that, but earlier in the mornings are best before I start streaming. But because once I start streaming, I'm usually streaming for the rest of the day. But yeah, I've completely lost my train of thought. I don't know what I was doing. I want to be working on a tutorial right now, but all the tutorials that I'm trying to follow through are freaking breaking. It's like I've gone through a bunch of really good ones, which, by the way, Trevor, like, there's some really good ones if you're ever looking to switch to Unreal. But the ones that I wanted to do, I can't. Although I did just get an idea. As I was showing this, I might actually have some idea of what this is. Let me try loading this. I have an idea. I don't think it's going to matter what I load. I gotta remember how to... Or... Wait, do I just... Maybe I could do that. I have an idea. I don't know if this is gonna work. So new... Let's do third... Yeah, need third person. Yeah. Sure, we'll do that. Blueprint, desktop, starter content, yes. It's definitely what I want. So it occurred to me that I wonder if it literally is just the base, this. But they're not looking around though. But maybe if I drop them in. Starter content. Can I just do the Manny. Whoa. Okay, there we go. ABP. Animation blueprint. Where's just straight up Manny? CR control rig. Manage, yeah. Trevor, you don't overestimate your abilities, Mr. Yeah. To show Quinn. I'm looking for just how to, like, where's just the straight up, just drag them in. But I think it would, they normally just label it as BP. Characters? Mannequin. Mannequins. Meshes? That's the full on mesh. Rig poses. Manny? No, 'cause that's literally the different poses. RTG. Oh! Maybe it's just sitting. It's not going to be that, is it? Because this is... I don't think it's that. They're not looking around. Mannequin UE4. This might be a bust because they don't give you any information. So I'm just pot-shotting, trying to guess what I'm supposed to do. Oh, I forgot. I still have a search query. Oh, it's doing... Oh, okay, no wonder. It was finding everything underneath there. It's control rig. IK. Physics asset. IK retargeter. Yeah, this might not work. Starter content? Blueprints. No. Yeah, that's a shame. I don't know. I don't know. It's super frustrating. Well, it is. No, that's the actual third person. Wait, what's the difference? Character, avatar, yeah. Does that become game mode override? Third person game mode. Mesh materials. Yeah, they're not looking around either. Oh, wait, is it? No, they're just... Yeah, okay, they just default look to the left. I imagine that I could set up the look animations, but like I don't know if I would set it up right to know that it like did I have it correct to match what the tutorial's going through, but I don't know. Yeah. Frustrating. All right. Yeah, so
We'll return a position.
this is what I
To our
want.
first problem. We'll open up Manny's character blueprint, and we need to
It's like open up Manny's character blueprint, but I don't have that.
somehow provide the perception system the character problem. We'll open up Manny's character blueprint, and we need to hit apply. Just click the drop down next to your design.
So they're using 427.
And select the source code checkbox, then hit apply. Now back to our first problem.
They don't have starter content. All right, maybe it's something in 427. Maybe. No, I don't want to save anything. I don't care. All right, so let's create a new project in 427. Maybe I don't have 427. I thought I installed 427. Oh my god, I'm gonna install every single freaking version. That's our disk space. Not looking good. 427 options. You did not have starter content, but I want it. They did have debugging enabled, but they didn't say that you need it. I think they just said you needed the source code.
The source code from the launcher for your engine build. Just click the drop down next to your desired engine, and select the source code checkbox, then hit apply. Now back to our first problem.
Yeah, so I'm gonna not do that one. Get rid of all these. I don't need them. Parts are 21 gigs. Jesus Christ. I gotta figure out where I can ditch some disk space. I am getting very, very low. What can I get rid of? How big is this? It's only 20 gigs. It's 8 gigs. My Blender folder's kind of big, but yeah, my Unity folder is massive. I don't know what else I can do. Alright, so these ones are all failing. I don't know how I can... How do you... remove... Do I just delete it? Just like straight up just say I'm just delete it from the... I don't know. How do you... right click, choose delete. There is no... Oh, this is from 2015. Right click. No delete! Yeah! June 23rd. Exactly. Alright, I'm gonna guess it's literally just let's see, breaking down components. Yeah. If I remember right, first game tried 2 and 3. All of these failed. This is fine, this is fine, this is fine, this is fine. Okay. Oh wow. These did not take up much space, so there's really no point in me deleting them. Okay, so now we have 4 to 7 available. We'll go ahead and launch this. See if maybe there's like a default project and they're just using a default project, maybe? I don't know. And I just wasn't seeing it because I was using a different version. Hopefully it's something as easy as that. Whoa. It's very different. 5 is definitely a lot more sleek. Games, film, television. Okay, it's probably games. Unless, do they have... No, film, television, architecture, okay. Flying, puzzle, rolling, third person. I'm gonna guess. Third person? Probably. Maybe? Yeah, none of this is like actual full-on asset content that looks like what the demo is. That's cool. So, try this. Project settings, blueprint master. Okay, yeah, sure. Sure. Not looking promising. Oh wow, so much different. It's definitely going to take some weird getting used to, but also the same sense of like, this isn't what I want to get used to. Content browser. Blueprints, third-person character. I don't think this is. Yeah, I don't think this is right either.
Different actors with how and plus functions will be the range. Select to create class and wait for this to compile variables. Blueprints read write just for that added flex. First custom with actor some pre-made example classes in the main.
Oh, I'm in the wrong course. Which, this is the other one. I can't get this one to load. This one won't load, so I can't finish that tutorial. Where'd it go? This one. Yeah, here we go.
We'll open and select the source code checkbox and hit apply. Now back to our first problem. We'll open up Manny's character blueprint.
Open up Manny's character blueprint, which is...
And hit apply. Now back to our first problem. We'll open up Manny's character blueprint.
What did they do? Third person character? Okay, so maybe that is right? Event graph. Where's the watching window? Why can't I watch you in window? Dude, you suck. That's frustrating.
We need to somehow provide... Now back to our first problem. We'll open up Manny's character blueprint. And we need to somehow provide the perceptions.
Gamepad image, yeah. Okay. But theirs was like, theirs had this looking around thing.
System, the current...
But mine doesn't do that.
We'll open up Manny's character. Is visual to get them to, as you apply.
Where did they demo that? Oh yeah, here it is.
The perception system calls a function called getActorEyesViewPoint, which returns a location and rotation that the perception system will use to do its line of sight checks. By default, getActorEyesViewPoint will return a position above the character's capsule using the eye height variables.
Did they program it to do the left and right movement, and I just...
As you can see, that location and rotation doesn't follow Manny's turning head.
Maybe they...
Override getActorEyesViewPoint.
creating a C class, obtaining
obtaining
solution class declarations.
So we need to override it in our own C++ based character class. We can do this by going to File, New C++ Class.
Alright, I don't know, I'm gonna try and follow along. It's just... What?
Based character class. We can do this by going to File, New C++ Class, and we'll be presented with a panel that contains a ton of commonly used classes in the engine, and these are probably familiar to you. You can hit show all classes, and that will show all of the exposed classes in the engine. But we're going to go back up, and we're going to select our character.
Okay. Character. I wish I could put the window out.
Call it an advanced character class, and we'll expose that to the public.
Advanced character.
For example, if we made a plugin or a module, public just means that I could use that character class from my plugin code. If it was private, I'd be denied usage. This will create two files, a header file and a CPP file. We'll go over these later, but for now we'll create class. Since we're creating a C++ class in a blueprint project, the engine will automatically turn it into a C++ project for you. As you can see, the engine has generated a Visual Studio Solution file,
Wait,
a
what?
source code folder that contains our newly added class. Since we're creating a C++ class in a blueprint project, the engine will automatically turn it into a C++.
Okay.
project for you. As you can see,
So yeah, they don't care about the output mark.
the engine has generated a Visual Studio Solution file, a source code folder that contains our newly added class, and a Visual Studio project folder. But for now, let's open up the solution.
No. Mine did not. Advanced characters are in use, but what?
This will take a and a Visual Studio for you. As a project, the engine will automatically turn it into a C++ project for you.
But it didn't. Okay. Generate visuals. Sure. Go ahead. Let's see if that works. Oh. Oh, that would explain a lot. Sure, why is it trying to use 19? Was it 22? Yeah. Browser. What version? The same average. I had to update the Visual 2. You uninstall Visual 19. Not sure. Okay, so Apparently people are saying they're using 2022. Alright, so let's go ahead and get this going. Continue without code, that's not the point. How do I actually have no idea how to even do this? I already have it installed. I don't need to install the whole thing again. Studio Treasure. Oh, okay, here we go. Modify, I see. Workloads, game development with C++. Game development with C++. Okay. The installation details and game. Visual Studios. And the installation details, which are under game development with C++, optional, Visual Studio tools for Unreal Engine. There's test adapter, Unreal Engine installer. That option is not here. IDE support for... Might be that. Maybe they renamed it. Visual Studios testing tools with unit tests for Unreal Engine. I don't know if that's relevant, but sure. Okay. Select the individual components tab on the top under installation details. Expand desktop development. Individual component and installation details. Expand desktop development. I don't have that. Optional Windows 10 and D. Let's see. this is sufficient. Windows 11 SDK. Okay, sure. So modify to complete the installation. Sure. Okay, sure. It's one thing after another. Oh, I wonder if that's why it couldn't recompile, because it didn't have the things, maybe? Oh, yeah, we should probably close it. Might be a good idea. Try again. Oh, we're not going to get much done today. Okay, how do I specify? Show integration tool via the Unreal Engine Marketplace website. Let's show. Instructions for installing. So if you build Unreal Engine to okay. Installing Visual Studio. The tool requires the idea of Visual Studio. You can as of Visual Studio Show, you no longer need this plugin to view information about blueprints of C++ code. Okay. Does it give more stuff than just that, though? Sure. Still unable to add the Unreal test adapter. Oh, god dang it. Unreal Engine test adapter. No, I did that. Yeah, I did do that one. Open your solution, Visual Studio. Oh, okay. That obsolete. Install the plugin a couple of ways. Through the Epic Game Launcher, select the Install to Engine option with the launcher. Epic Game Launcher. What? Okay. Let's bounce out of this. Visual Studio Integration Tool. Okay, go ahead, hit that, I guess. I don't know what it just did. Did it do anything? Can't add the cart. It says free. Select Install to Engine option with the launcher. What? Through the Epic Games Launcher, that's this, select the Install to Engine option with the launcher. Options. Install the engine? No? 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 I'm going to plug into your account. You'll have an option to open the launcher in order to install it as detailed above. But I can't. For using the Marketplace website, you can add the plugin to your account. Okay. You're welcome. Open in launcher? Yeah, sure. Installed engine. Now it's there, you little bugger. Oh, you're stupid. Actually. I'll put this on all of them. At least those two. Oh, it's very small. Put it on all of them. Okay. Okay. So, part of this, now I'm curious. Yeah, this isn't, I need to show in folder. I'm going to make this go away. Yeah, there you go. Okay, we're gonna try breaking down components. Put this here. Refresh, please. Thank you. Okay, still didn't work. Kind of expected that. Okay. What was the other one we were just trying to do? To this one. Following modules are missing. Wait, what? I literally just opened this one. Okay. That's weird. Um. Block. Player start. BP third person. Browse to asset. Okay, I have no idea if this is actually gonna work, but alright, let's see. Let's go back to here. Oh. It's not even an option in here. Well, that's frustrating. Because now I can't even open this other one. It's 427. Test server show built with a different version of the engine. It was not built with a different version of the engine. But it doesn't want to build any engine now, so screw you, apparently. Alright, well, where's the equivalent then to create a C++ file? I have no idea. Oh, AFK a minute. Okay. Yarg. Critical Role is having something called Puppy Roll. Oh. What is this? I don't see anything specific about it right now, so I don't know what you're referring to. Drop in Discord, no worries. What was it? Yeah. The puppy roll. Jolly. Wait, what? Oh, okay. So it's not that Critical Role is doing this. It's somebody else is doing it, and some of Critical Role's members are participating. Interesting. Looks like it might be a one-shot. Yeah. Yeah, it's interesting. Oh, I'm so lost. Important to know. So, build new level, new asset, recent save, export new recent projects. New C++ class. Okay, so that is now here. Got it. Okay. Found that. What did they do? New character, right?
Go over these later. Class advanced. Go hit show all classes, and they will show all of the exposed classes. These are probably in the engine. But we're going to go back up. We're going to select our character.
Okay. Character. Advanced character public. Okay. Project now includes sources. Please close the editor and build from your IDE. Successfully added. Would you like to edit the code now? Must be recompiled. Okay. Okay, it's loading the right version. That's good. That's a plus. These project files are... Wait. Projects are not supported or need project behavior impacting modifications to open. Projects not displayed. information. I don't understand. Unreal Engine configuration. Oh, it's okay. Configure Unreal Engine features here. We'll run a check for each. If you're installable and configuration, check overall. Click here for status. Select the project. Okay. Unreal Engine naming convention checker. Enable Unreal Engine naming. Just. What? When enabled, the Unreal Engine naming convention checker will check for performance. It will display found issues. Suggestion warning error. I don't understand. Okay. Just whoa, what are you, whoa. Oh, it's doing a thing. Well, it's doing something. I don't know what's going on. I have no idea what's going on. Oh my gosh. Okay, well, it doesn't seem like it's doing anything anymore. I don't know what it's wanting me to do. Configure. Okay. Sure. You're happy now? I guess that's all that matters. Enable Unreal Engine naming convention checker. When enabled, the Unreal Engine naming convention checker. Options. Unreal Engine. Clear. Remember. Engine. I don't know what it's asking. Okay. Well, I'm gonna guess that that's minimal thing. Oh. Well, that's clearly not happy. I have no idea. I have absolutely zero idea what I'm doing. Based on your solution, made it install extra components for full development. What would I need to install? I don't know. Desktop development with C++. Okay, sure. Seems like it's recommending those. Why not? You're some kind of one-shot charity thing. Oh, yeah. Yep. Oh. I have like at most like an hour and a half left before I have to leave. Yarg!
Haruk fattened one Crisis. Between saving Private Ryan, $70 million, Interstellars, $165 million, and The Martian, $108 million. America has spent nearly $350 million trying to rescue Private Ryan, $70 million, Interstellars, $165 million, and The Martian, $108 million. America has spent nearly $350 million trying to rescue Matt Damon.
Yep. Whoa. What just happened? What? What is, I don't know what this is. Okay. I'm stumbling through this. I have no idea what I'm doing. Oh my god. What do you call an android's sleeping bag? Oh dear. I don't know if I even want to ask. Installation complete. Cannot find things yet. Snug. That's silly. Cannot open source file. Okay, yeah, I get it. I get it. I don't know what you want me to do though. Yeah, I still don't know what this is. Okay. I don't even know build solution. Sure, I don't know. Said you have to build it. Did I mention that I have no idea what I'm doing right now? Build success. Apparently, despite not finding things, I guess. I don't know, sure. Let's reopen this. Hey! Okay. Plugins available. One asset editor was open. Was you? I don't care about you. What is you? Which plugins? What you? Visual Studio. Visual Studio Code integration tools. This. Go ahead. Have fun. Enjoy. Okay. Oh, you've been running.
Now that we've got Visual Studio open, it has generated automatically turn it into a C++ project for you. As you can see, the engine has generated a Visual Studio solution file.
Do we actually have that now? I mean, we should, because we were just in there.
A source code folder that contains our newly added class, and a Visual Studio project folder.
Source.
Now, let's open up the solution. This will take a while to load the first time. Now that we've got Visual Studio open, we can
Okay.
open the Solution Explorer. You can
Solution Explorer.
see our project, the config files, and also the source folder. This contains our target rules and module rules, which are both used by Unreal Build tool to compile your project, a module implementation, and also the source folder. This contains our target rules and module rules, which are both used by Unreal Build tool to compile your project, a module implementation.
Oh, I'm so confused. Character Mars got a dip. Say, really enjoying his tutorials. Oh, I have no idea what I'm doing, but take care, Character Mars. Thanks for hanging out. Do take care.
And also our source files and the character class we added. This is the header file of our new advanced character class. A header file contains the declarations for our classes, their properties, and functions. They're analogous to the My Blueprint window in the Blueprint editor. Over here, you'll notice that our class name is prefixed with an A.
Okay. They're in the header, right? Wait, yours not all underlined. Yeah, so you're in the header. God, I wish I could. Let me try refreshing the. I think it's because it's YouTube.
If it was private, I'd be denied
Yeah.
usage. This will create two files, a header file and a C class project. Declarations for our implementation, and also our source files and the character class we added. This is the header file of our new
I really, really, really want stats for nerds. Ah, you're so frustrating.
advanced character class.
Okay. I keep loading the wrong window.
A header file contains the declarations for our classes, their properties, and functions. They're analogous to the My Blueprint window in the Blueprint editor. Over here, you'll notice that our class name is prefixed with an A. This is the standard for all actor subclasses. We can also see that the character class is placed to the right of the column, and this indicates that our parent class is the character class. To the left of our class name, we have the class key and the module that we're exporting from. Now, I'm not going to go into modules in this talk, but it's worthwhile checking out our documentation on it. Above, we have a number of included header files. The core minimal header file is a default include when we create the class. The character header file is needed, as header files are used to reference other classes, otherwise we would get a compiler error because C++ won't know where the character class lives. And the last include is the generated header file that the engine produces to automatically expose the classes, functions, and properties we want to blueprints. This is called the UObject system. Below, we see a number of macros. Macros are normally used in C++ the same way that they are in blueprints. Effectively a template to do some kind of
Oh! There's the sample. They were in the freaking comments this whole time. God dang it. We'll see how far we can get in 5.
In this case, both the uClass and generated body macros are used as generators for the UObject system. Any subclass of an Unreal object, also known as a UObject, that is wrapped with these macros will expose that class to blueprints. Now, unlike normal C++, whenever you construct one of these UObjects, it will be tied to the UObject system, and so you don't need to manage its memory. You can just create it, and when nothing else is referencing it, it will automatically be cleaned up from memory through garbage collection. Now, inside of our class declaration, we have the constructor, which is used to assign default values for properties you've created. It's also the place to create and add components to your actor. And you'll see that there's some familiar names, like the begin, play, and tick functions. These are the native versions of the blueprint equivalents. There's the setup player input component, which is the function that you would use to bind input actions and axes to functions. There's also the public, protected, and private access specifiers, which are analogous to the ones you can see in a blueprint function declaration or the private checkbox on a property.
If you haven't used Blueprint's access specifiers before, they control whether a function or property can be accessed from another class. Public means the target can be accessed from anywhere, protected means that only the owning class or its subclasses can access, and private means only the owning class's access, not even subclasses.
Now, we need to implement the functionality to provide the perception system with the correct location of our eyes. To do this, we're going to access a socket on our character's mesh and provide the location and rotation to the perception system. So firstly, we need to create a property. We'll give it a name type and call it iSocketName. Now, this is a valid property declaration in C++. However, we want to be able to modify this property in blueprints, so we need to use this uProperty macro. This is a special macro that is part of that automatic process I mentioned before, and it will expose the following iSocketName property to the engine. This is necessary whenever you need blueprint access to a C++ property. Inside this macro, we can add a number of property specifiers. These specifiers tell the engine how this property is exposed to blueprints. For example, edit defaults only will only allow you to edit the property in the blueprint class defaults. Edit instance only will show the property in the details panel of a selected actor, and edit anywhere will show the property in both. Now, you've probably noticed that I'm getting some code suggestions showing up. These are provided by those extensions I mentioned at the start. Now, back to our code, we're just going to use edit anywhere. We can optionally tell the engine whether our property can be read and or modified by blueprints. In this case, we'll just use blueprint read-write. Now, we need to add the functionality to get the location and rotation of our socket. If you remember, we were going to override the getActorEyesViewpoint function, so let's do that. We'll right-click our class name, and then select Implement Virtual Method.
This Implement Methods panel is a feature of Visual Assist. So as a reminder, if you don't have Visual Assist, just follow along and you can handwrite the code it generates.
This panel is completely analogous to the Override Functions menu in Blueprints, where virtual methods are functions that can be overridden by child classes, just like in Blueprints. In our case, we want to override getActorEyesViewpoint, so let's search for it, select it, and hit OK. This will add the function declaration to our class, and then the implementation, also known as definition, will be in the corresponding advanced character CPP file. In here, Visual Assist puts in some boilerplate code. There's an exception, this P file, also known as definition, will
Okay. Under class, generate body, under public, and character. Okay. Pretty sure I did all that right, despite everything still being red. I don't know.
be in the corresponding advanced character CPP file. In here, Visual Assist
Okay. Advanced character primary can take true. Advanced begin play. Super begin. Get active. Okay, this is what we're going to do. Wait. Okay. So again, that should be what they have there. Unless I typoed something.
puts in some boilerplate code. There's an exception that's being thrown just to catch us in case we forget to implement our function, but there's also a call to a super function. These super functions are the same as calling the parent function in Blueprints, where if we call it, it will also run the parent class's version of that function. In our case, we don't want to call it, but instead replace it with our own functionality. So let's do that. Now this code requires a bit of explanation. Our function accesses our character's mesh, and from it, we get the socket's location and rotation by providing this iSocket name as a parameter to those calls. The result is then stored in the location and rotation parameters. These parameters have been passed in by reference, so when we assign a value to them, they act like they're returning those values to the caller. In this case, we're returning the location and rotation of our eyes to the perception system. Now that's written, we need to close the engine and then compile our newly added code. We can do that by going to the top of Visual Studio and then clicking the green play button that says Local Windows Debugger. This will firstly compile our code and then clicking the green play button that says Local Windows Debugger.
Oh, okay.
This will firstly compile our code and then attach the debugger for when we want to debug our code. The first time this compile happens, it will take a while, so I've sped this video up. Now that we're in the engine and we're compiled, what we need to do is we need to get our character and then we need to reparent our blueprint by going to File, Reparent Blueprint. Now you can see that our newly added character is there. Cool. However, what we need to do is we need to specify our iSocket name. So let's open up our...
So if we do file, I don't think it's going to be under there, so file, reparent blueprint. Oh, there you are. Advanced character is in fact there. Look at that. Okay.
Skeletal mesh, and in here I've previously added a socket called eyes viewpoint that's positioned over the eyes. So let's go back to previously added a socket called eyes viewpoint that's positioned over the eyes.
Okay. So that's under SK mannequin. Which that's the skin mesh. Where's the escape mannequin? Okay, that's not helpful. Neck one head. Okay. maybe head. And socket. Oh god. Sure. Sounds great.
So let's go back.
Oh, right. Helps to name it right now.
Previously added a socket.
Eyes viewport. Oh. What? Why is it 2? I don't want you. Okay.
Called eyes viewpoint that's positioned over the
Point. Sure. Whatever.
eyes.
So let's go back to the character and type that in.
Advanced character generator. There, set yourself up for no sleep tonight. Why would you do that? That doesn't sound like a good idea. It's like Spore. Fair. Fair. Spore. Very much a love-hate relationship. So, for one, if you didn't know, Spore is not what it was supposed to be. The original concept for Spore was not a cutesy fun game. It was like dirty, nitty-gritty, like very hardcore, like rippy, shreddy, borderline adult type sort of game. Like their original content was going to be, like heavy. Like for me, I was very interested in the eating part of it for reasons. I also hard to believe it's made by EA since it's good. Oh, that's funny. But so I am sad that Spore never became what it was going to originally be. That makes me sad. The other part is Spore is fun until space, and then space is just like, okay, I'm bored. I do not enjoy the last phase. I find the last phase is just boring. I don't know if I ever even finished the last phase. So I get bored with it after that. But, yeah.
Now we should be able to compile it. And in here, I've previously added a socket called eyes viewpoint that's positioned over the eyes.
So let's go back to the character and
Okay. Go back to the character. It's eye socket name. And the character. Eye socket name. There it is. Okay. Viewport. It's because I misspelled that, but that's fine.
type that in. Now we should be able to compile our blueprint and give that a test. So now that we're in the viewport, let's jump in. We'll enable AI debug by pressing apostrophe and then numpad 4 for the perception. And you can see
That's interesting. Okay, compile, do that, do this. Third person. So what do they say? We go in, hit. What? I already forgot what they said.
So now that we're in the viewport, let's jump in. We'll enable AI debug by pressing apostrophe.
Apostrophe. Oh, that's cool. And then they said 1 on the keypad. No, 4. Perception. What is that icon? Yeah, controller BP. I don't know what that icon is. Something's wrong, maybe? Okay, so I'm guessing that this is not set up to have perception. Tap apostrophe to close or hold to select new pawn. Control tilde HUD, control tab debug, show tab spectator, and app match. That's cool. System. Okay. Yeah, you typically take your sweet time enjoying all the phases, so by the time you get to space, it's time for a break and then never go back to it because space phase, while fun, is just too slow. Besides, the sort of guy that wants to own the whole galaxy and nobody got time for that. Yeah. yeah, I get bored in space. But yeah, I agree. Like all of the other ones are decent. My favorite is just the second phase. The first phase is okay. That one's okay. My favorite's the second phase. Yeah. Where you're actually the critter wandering around and doing stuff. But of course that one's my favorite. Alright. I suspect that there's just AI perception. Interesting. Well, what if we just do that? I don't know. AI perception. What happens if we do that? Okay. Perception with this. And then AI perception with that. It doesn't work. Yeah, there's probably stuff that needs to be set up that I don't have set up, that I don't know how to set up. I recall you like the tribal one the most? Yeah, the tribal one's decent too, but I like the tribal one. There was something about it that I just remember being kind of a nuisance, but I don't remember. Yeah. I think if I remember right, my order of preferences would be the actual species wandering around, phase 2. Then probably phase 1 I would like more than the tribal, but that's a really close call. Like the tribal one and the first phase are two, like they're kind of close. Like I like them both. Third would be the city one, where you're on the planet with the different like your cities thing. That one's okay. I kind of like that one, but and then last is space. Space is just boring. Yeah. Shred. I don't know what to do now. I don't know what to do. It's not going to let me open this now. It's super frustrating. Wait. Oh! I was actually doing the build now! Oh, heck yeah. Okay. Makes sense you lay the two first. Yep. Yes, indeed. Okay. We're back at this. This is good. But now that I have this, now I could potentially go and find this legacy thing. Legacy. Let's see if we can find it easily. Let me do that. Literally just called blueprints. Very helpful. Yeah, about that. Free. Let's see if we can get it to actually load. For whatever reason, it doesn't like to put stuff in here sometimes. Breaking down components. That was the other one. Sure, open and launcher. I don't know, being mean. But see, there you go. Now you freaking load this stupid thing. Great project. Thank you. Okay, go here. Here. Yes. There you go. Can I make you the default so you always do that? That'd be great. Four, 2, 7, sure. Oh, god dang it. Forgot to rename the bloody thing. It's just stupid. I figure out how to rename it something. I forgot to click public. I don't know what that's gonna do. That was a sound? What the heck made that sound? Sure. Have fun. Enjoy. Sounds great. Okay. Oh, look, we actually are in this thing now. Okay. Cool. I don't know where. That's funny. Alright. Go have fun. Alright, so there's probably something in here that's supposed to. Oh, this one is actually doesn't have like errors and stuff, which is cool. Go away. in our header, uClass Blueprints API advanced character, by public advanced character void get actor eyes point. Okay. Socket name. Now. F12. No, that's not right. How about you? This. Advanced character. This is the header. I don't want the header. I want. Oh, okay. Here's a CPP file. Okay, so we got that.
Implement those calls.
Okay. Include advanced true begin play. So something I did somewhere. So oh, don't care about you. You can leave a message if it's important. Okay. So under advanced character. Wait. Oh, it actually has auto-completion this time, which is cool. Okay. Super begin play, advanced tech, that should be fine. Okay, and we're still open, so we need to close this. Build. Where are you? Oh. Well, that was in fact an error. Okay. Show. Print. Office. What am I in? Build data registry. Print office built. Oh, okay. It's got to be this. Yeah, this is so. So this is where we're at then. So where is content browser asset? Interesting. Oh, girl, looks pretty. This is not mine. This is a tutorial asset, but it is pretty. This is all already there. It's pretty cool. butterflies. Yeah, so this was all part of a tutorial thing, and I had to go back to Unreal 4 to run through this tutorial, but it's a somewhat generic thing on C++ and blueprinters, which actually now my title is wrong because I switched tutorials. But hello, welcome. How are you doing? Hope you are well. Let me update this. C++ for blueprinters. I am trying to go through this tutorial. We'll see how that works.
The
All right,
result
we
is
did
then
this.
stored in the location and rotation parameters. There is a gameplay button that says local wheel. Don't need to spend
And then,
to reparent.
oh,
and
right,
blueprint
okay.
by going
So now we need to do the reparent. Not blueprints. It's third person. No. I thought it was third person. Right. BPS character spawn, print show. I don't know who it's supposed to be. This is what we just created, so it at least found that. So that's good. Little girl, you're okay. I'm surviving-ish for now. Okay. Today's been a real struggle when it comes to Unreal. I've been trying to go through tutorials and I've been hitting a lot of roadblocks. First few days were going really well. Okay, third person. No, there's nothing. Oh, because I'm not in a third person controller. Where the heck is Manny? I'm so confused. Oh wait, I don't understand. Okay, maybe content. Oh, this doesn't make any sense. See, like this, there's these roadblocks that I don't understand what I'm doing wrong. So,
and provide that the will open up Manny's character code
they're
checkbox.
exampling this
Now back to our
character, this Manny character, and they're in this open scene here. I don't think that's the same. I don't think that's the same area. No, that's not quite. I mean, it kind of looks like a little circle with this, but it's not quite the same because that has those. Yeah. But I have no idea. So the comments were saying, like, where do you get the tutorial file? And I loaded this, but this is not this is not the same thing. Let's struggle with things too. You seem to be doing a good job. Not presently, but earlier I was running through the other half of a block placement tutorial. That one was good. That one was fun. I don't know if I have that one up, but still, I probably closed it. I've got it in my notes. But have you done this one? This block tutorial one was good. This one was really good. I like this one a lot. You done game dev? Are you interested in game dev? Unity, Unreal, other stuff? Why is my phone going off? Oh, that's why. I don't care. But yeah, this tutorial was good. I ran through this one earlier today, and it's like adding
Clicking inside kit games.
I don't know if it'll show an example of what they're gonna do. But yeah, you run around,
Create
you
folder.
add blocks to the world and stuff like that, and have different types of blocks. It was a good tutorial. I like that one. I ran through a few others. Maybe we're on what, day 6 now, I guess. 8. Which actually I need to update my notes for that. 001. Okay, that's good. All right. They don't understand why I find it interesting. Yeah, I definitely find it interesting. But there's plenty to learn, and there's some really good starter tutorials too. That if you were looking to try and get into it, it's just a matter of, everyone starts from the beginning. It's just just got to keep trying. My problem is I really want to follow through this tutorial because there's this C++ for blueprinters. I want to run through this one. Then there's this balancing blueprint in C++ that specifically refers to this one. So I don't want to do that until I do this. But this one I can't find the scene for, so I can't follow along, which means I can't do this one. And this one is full on breaking when I try to run this one. Although I might have found out how to fix that now. So I might actually at least be able to do this one. But I will circle back around to that once I finish or give up on this one. But so I don't know what this third person controller, this Manny. Yeah, Manny third person controller is what they're editing. But I don't even have that. It's not in here. There's no third person thing. So empty character. I don't know. I have the starter stuff installed. Well, this one was 427. Yeah, starter content's installed. It would be nice to start something new maybe, but since you're in architecture and you need to study a lot of everything, you kind of stopped having time for everything. I definitely can understand that. An interesting point, though. Where did I see it? I just ran into something about that. Where was that? There actually was a subsection. Specialized blueprint nodes, developing. I have so many tabs open right now. Introduction, common UI, developing this channel. Gameplay framework. I'm looking for something in particular. This is what I was looking for. Yeah, literally. Unreal Engine 5 for architecture. I accidentally stumbled across this earlier. But it's because you don't know how to handle time yet. Getting better. Maybe someday I'll give it a try. Yeah, time management is definitely a thing. This isn't VTube. This is FaceRig. I guess that would be old school now. Someday I'll figure out a VTube thing maybe, but really I need to get an actual Badger model proper because this is not proper Badger. But yeah, I haven't looked at this Unreal Engine 5 for architecture, but if architecture is your thing, yeah, maybe spend a little bit of time just watch it. At the very least, could be just interesting information. But yeah, maybe check it out sometime. I have not watched this. I don't know anything about it. Just I stumbled upon it and was like, oh, I remember this. So there you go. Oh boy, I still have no idea how to get this third person character into here. Find players from project. Man, just looking at Unreal 4 versus 5 that I've been working with, it is so different. Like 5 is it's a pretty big jump. Developer tools. Content browser. Project launcher. I'm trying to figure out where the bloody plugins is. You are. Person. Nope, it's not that. Dang it. I don't know. I have no idea. I'd like to follow along, but I don't know where to get the starting project files for the tutorial. Where can I find them? Thanks. You are... this is old sample map from Unreal Engine 4.6 era. Interesting. Doesn't work with 5, so if you want to use a sample project, follow along. Yeah, so this is the wrong project. You'll need to download and install 4.6. This is not the right project. Take it to a wildfire damage show. I'm so bloody confused. Look where I need to go. It's nice talking to you. Keep up the good work. If you don't know what to do, remember rest. Resting always makes you see things better. Oh yeah, no, rest will be coming. Oh geez, we gotta go soon. It's board game night for me, so I will be heading off to do real life board games very shortly. Very much resting. But yes, take care. Yeah, I've got... at most I have like an hour, but I probably have like half an hour, I'm guessing. Okay. Blah, 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 blah. I'm seriously thinking I'm just stuck. I don't think I can do this tutorial. Which if I can't do this one, then that makes doing this one incredibly difficult. This one I may be able to do. Let me see if I could fix this. Breaking down was breaking, yes. Ah, yeah, see, now it's actually starting to build a channel. Okay. Volume channel. Oh, Jesus. Alright. Yep. Disk space went bye-bye. Oh, everything's coming apart very quickly. gotta figure out how to clean up some disk space. I think we're just gonna go ahead and call it. So I'm gonna have to do some cleanup work, figure some stuff out, and game night's basically right around the corner. So, yeah. All right, we're gonna end here. Ah! Thanks everyone for hanging out. As always, be well, be safe, be yourself, be kind, be all the good things, and have a great rest of your day.